install.
Is your computer showing some other? Oh, there you go.
Oh,
Okay. Ready?
yeah,
All right. There you go.
okay. Hey everyone. Uh, hey, thank you all. I hope you all are caffeinated, energized for the conference. Yeah, I know. This is our first talk in the JavaScript track. Uh, I hope I won't make it boring. Okay. So my talk is about building inclusive React applications, where I talk about the techniques and the best practices for front-end engineers in order to build, inclusive web applications. So, uh, a little about me. So, I'm a senior staff software engineer at Albertsons Companies. I have been working on uh, mobile applications, web applications from close to a decade. Uh, so I started my career back in 2017, but I started working while I was doing my undergrad. So, uh, I hope you all know what is accessibility, right? Anyone? Okay. I hope it doesn't sound like that. So, what is the significance of the accessibility? And specifically for web accessibility. So, when we build applications, we, we make sure that we build for everyone and which is usable by everybody, not just for the uh, normal users. We make sure that our web applications is accessible to even for people with disabilities or with motor impairments, visual impairments, you know, uh, people who cannot speak, people who cannot hear. Okay, it's more about building applications to wider audience, right? So, how many of you are working on the customer-facing application? That's great. So, do you know how many percentage of users are of your users are disabled? Okay, I know. It's not just about building applications for disabled people. It's about the better user experience, right? Let's take an example. Let's say you build an application, let's say video application, where you're in a noisy environment and you're listening to a video. Let's take YouTube, right? It's good to have transcription, captions when you're playing a video, right? So even in the noisy area, you could read through the captions and you could understand what's going on. Okay, consider the same scenario for people who cannot hear, right? All right. So it's not just for building application just for the disabled people. It's for better user experience and uh, making it more accessible. Okay. So this is pretty much about the web accessibility. So so what comes after this? Uh, the accessibility standards. How many of you are aware of Americans with Disability Act? How many of you know web accessibility guidelines? Web content accessibility guidelines? That's great. Okay. So, I'll tell you what is web content accessibility guidelines. These are a set of guidelines designed by one of the non-profit organization called W3C, World Wide Web Consortium. It's a non-profit organization where all the developer advocates or the accessibility advocates come in. They design these rules and guidelines and set of principles one should follow to make web application accessible to everyone. Okay, so there are different standards when it comes to web content accessibility guidelines. Level A which is first standard, and level AA, which is a second level of standard, and level triple A, which is a tall level, which is beyond what we call the accessibility. Okay, if you take ADA, Americans with the Disability Act, you just have to meet level AA so that you comply with American Disability Act. It's not just about the compliance, it's about the usability, right? So you build web applications, to make sure that you make it accessible to everyone. Okay, that's a first and foremost rule. It's not just complying with the guidelines, comply with the act and all. Okay, it's more about a developer has to think in terms of user experience, providing a better user experience to everybody. Okay, so that's where my passion starts. I want to build applications that should be usable to everyone, providing a great user experience, great revenue and great usability, more users, right? Let's assume you build a complex website where users are having hard time to find. Let's say you build a retail website where you sell groceries, right? So let's say you build a complex UI and where users are having a hard time to find their shopping list or find their products to shop, right? So that's not the case. It's not for normal users. When you build applications accessible in mind, you build simple accessible UI just for everyone. So this is one other act, 508, Section 508, Rehabilitation Act, which applicable for the government agencies, federal agencies, So these are pretty much of the compliance. So let's say you have a retail website, okay? Any of the retail website you have, okay? You have a retail website, and let's say if that website is not accessible to any of the users, they might end up in lawsuits. Okay, there is one of the famous retail chain that got they imposed a lawsuit. They had to pay $6 million just for not complying with the ADA Act. Okay, assume so the penalty starts with 75,000 and it goes and multiplies if you're not compliant with it. Okay, so let's talk about some common accessibility barriers. As you can see, I hope you all know the Breaking Bad character Salamanca, right? So when you build inaccessible website, this is how it looks. Okay, you cannot, you say there's a wheelchair access, but you cannot make use of wheelchair, right? What's the point in having that? So as per the WebAIM, which is a non-profit organization again, WebAIM is nothing but web accessibility in mind. Okay, they have one tool called Wave, which is an accessibility testing tool. They conducted a research on top 1 million websites, popular websites, and these are the most common accessibilities they found. Okay, so with low contrast, missing alt text, missing labels, empty links, empty buttons, missing language. I hope whoever worked on accessibility, they might know what this means. I'm going to cover all this. Okay, these are the pretty common pitfalls where most of the website fall into. So in order to avoid this, let's say alt text. Let's say you have an image tag, right? And there's something alt text. Does anyone know significance of what is that alt attribute for the image tag? Right. So if there is a visually impaired user, they are accessing through the website. If they want to know what the image is about, you mention the description about the image in the alt attribute, right? Same as the poor contrast. Let's say if a website has a poor contrast, a visually impaired user cannot read through it, right? Let's say I'm gonna demo these examples as well. And a poor keyboard navigation. Let's say you built a website. So most of the users, disabled users rely on the keyboard navigation. Okay, they make use of tab to navigate through entire website. Okay, and perform actions in order to navigate from each page. Okay, and the captions, as I already mentioned, if there are no captions or transcripts, let's say you have a video embedded in your web application and there is no captions, as a person who cannot hear cannot understand what's going on in that video. Okay, a person is playing an audio doesn't know what's going on, right? You need to provide the transcript for the audio too. So yeah, how do we fix this, right? How do we fix this common pitfalls, common accessibility issues? First thumb rule of approach, make use of semantic HTML. Okay, what is semantic HTML? It's nothing but you have header, body, and footer with so let's say example, you have header, navigation, main, footer, right? There are semantic tags, default ones, right? Like button, anchor tag, button tag. All is a semantic tag. How many of you use div to create a button? Anyone? Yeah, I know. So we already have a button tag. Why do we have to use div to create a button, right? Doesn't make any sense, right? So when you build a web application with a semantic HTML tags, you don't have to worry about the accessibility. The semantic HTML tags will take care of the accessibility, right? I'm going to show all this demo at the end. Okay, and the next part is make use of area rules, right? So how many of you know area? Accessible rich internet applications, they call it. So it's an attribute that we make use of in HTML, right? So you call it a area labeled by, area live, right, and so on. So this is going to be another talk on area roles. It's very huge, right? So in area there are something called roles, states, and properties that we make use of. These are nothing but attributes, HTML attributes that we use. So when do we use area? Okay, first rule of thumb is try to avoid using area roles. Okay, always make use of semantic HTML tags. Okay, so when you are not able to make your website accessible at some point in your website, that's when you will start using area. Okay, one such example, you built a menu bar in a website. In order to make it accessible through screen reader, this is how you define. You say area label, main navigation, and each of these menu options has a role, right? As you can see, role home. So it means it's a menu item. I'm saying a menu item that will navigate to home. Another menu item, it will navigate to about section, and another menu will go to contact section. Okay, this is how we make use of area label or area roles to make your website accessible. So we use as a disabled user, they use different assistive technologies like screen readers. So like if you take let's say if you take Mac, there is something called VoiceOver, which you can make use of. If you take Windows, there is NVDA. That's not inbuilt, you will have to install. And there is one other tool called Wave by WebAIM, as I already mentioned earlier. So people make use of these assistive technologies to navigate through all the web applications, right? So as I already mentioned, try to avoid using area roles you use only when necessary. One great example here, you already declared make use of button, okay, and you have given a role called button. You don't have to do that, right? This is going to confuse screen readers. Since you already created a button with a semantic HTML tag, you don't have to really define it. Let's say if you built a button with a div tag, you're going to have to mention that role as button, so that an assistive tool can detect it's a button. Okay, same as the correct way of using is the below one, the next one. Okay, try to avoid misusing of area roles. Use only when needed. And another another technique where you make use of area role is through dynamic implementation. Let's say you have a content on a web page that gets loaded only when the API call is made, or when the API call is completed. Okay, so you rely on something called loading state. You keep on waiting when the API call is going on. You show something called something is loading on the website, so that the screen reader detects that something is loading on the website and it reads out. When the website is loaded completely, you're going to show the content on the web page. So in such scenarios, you can make use of area leave polite, so that that attribute itself will define it start reading when the content is loaded completely. Okay, so that's how we make use of area live, and we conditionally render the details to the screen reader. As you can see, that we depend on the loading state. When the loading is done, we say it's alert. Otherwise, we show the status. That's it. Okay. Another technique was focus management. So, how many of you are aware of focus? Okay. So, yeah, focus can start anywhere. Okay. You build a web application. Let's say you have a form which collects the user details like first name, last name, and everything. So the moment you load the page, you want user to enter their first name. So that's where your focus starts. So your focus is on the first input element of the web page called first name. Enter your first name. So there are techniques that one should follow in order to implement that focus. So one is we need to understand in terms of accessibility. The requirements comes from the accessibility advocates. Okay. As a developer, we try to cover as much as 30% of the accessibility issues, like as I mentioned, alt text, missing alt text, and color contrast and everything. Okay, so understand your focus, where the first element in the web page needs to be focused. All these requirements will come from the accessibility team. They will guide you based on the mockups that are given by the designers. Okay, and the next step is implementing the focus tab. Let's say you have a modal. You want to make sure that user is not getting lost in those modals when they close the pop-ups, right? That's where the focus tabs come in. Okay, this is one such example how to implement this focus tabs. Using useref. So we make use of React hooks to achieve the focus. So one such example, we created a model, and we call it dialog, role dialog, as you can see. And once a dialog is get closed, we want to take user back to where the user has left. Okay, so that's the focus tab is for. And programmatic focus control, where you can logically achieve the focus on a particular element that you are desired to, that you want to focus on. Okay, and how do we test all this focus related stuff? just by make use of existing Jest library that comes with a React, right? You can write unit testing test cases for this using Jest, one such example. And to visually show it on the UI, you make use of styles just by using that attribute called focus, right, for a button, okay. So these are pretty much okay. And so how many of you think this is correct? You? Okay. Anyone? Okay. So many of developers think that okay, I have to build a UI what product has given, okay, what the designer has given, and their major focus is to build a UI and ship it faster, okay. They don't think about the accessibility at first, right? They always think let's deal with accessibility at the end during the QA cycle, okay. This is where we're going to end up if you do that, okay. You see accessibility depth everywhere, right? You see so many accessibility issues are reported and you're close to your release timeline, okay. So let's not take accessibility at the end. It's always recommended think accessibility at the first before you start developing, okay. Go to the designers, involve accessibility folks, let them review the mockups given by the designers. They can find as many as issues during that phase, okay. Before it goes to development cycle, most of the issues get caught during the designing phase, okay. You might be getting mockups through Figma or Zeppelin, right? So it has to been reviewed by the accessibility advocates. They give review inputs, feedback, and it goes to another cycle of designing change, and then it comes to the developer. Most of the color contrast issues get caught during the designing phase. When it comes to the developer, as a developer, we need to make sure that we need to have right set of tools in place, right, while developing the component. There is this. I hope you all know what is test-driven development, right? TDD. Make use of writing unit test case for accessibility, okay. So so never ever mix up with a functionality testing, and never ever mix accessibility testing with a functionality testing. It's good to have accessibility testing as a different track, okay. So what are the essential tools for testing, right, for accessibility? So there are few automated testing tools. As I already mentioned, unit testing, make use of just Axe, okay, and Axe Selenium for automation. I hope you already know Axe by DQ Labs. They have open source libraries. So just Axe is for unit testing, Axe Selenium. Either you can use Selenium, Cypress, or Playwright, whichever works for you. For automation testing, A11 by Adi Osmani. I hope you might be knowing, he's a pretty famous guy from Google. And Axcore React is again from the DQ Labs, okay. So these are the tools that used by the accessibility QA for testing for any of the accessibility issues. And these are some other popular accessibility testing tools. Axe, as I already mentioned, by DQ Labs, Lighthouse by Google Chrome, Wave by WebIM. And so let me run into a short demo, okay. So here I have a React app. Oh, hold on, slow down. So I have something called Axe Dev Tools here, okay. I'm gonna run a full scan of the page. It found two issues. It says element must meet minimum color contrast, okay. Does anyone can read what's here? It says sign up. Can anyone read here until unless I highlight it? right? This is a poor contrast. So this is one of the accessibility issue, okay? And other one is form elements must have labels. Looks like doesn't have labels, okay? So I turned on the voiceover. So it's not reading what's there on it, okay? Looks like it says leaving toolbar React app. It doesn't say, it doesn't read out. It just said tick box, nothing else, right? So yeah, I think I'm pretty much out of the time. So sorry. Yep. Thank you so much for everyone. Yeah.
Hear me okay? All right. I love when Canva doesn't cooperate. But if you don't know me, my name is Caleb Garner. I am a full-stack developer based here in Addison, Texas. But today we are going to be talking about web performance. In today's technology ecosystem, there's a great need for speed. I'm not apologizing for that joke, but there is a need for speed when it comes to our web applications being as efficient as possible. And if you don't believe me, I have some statistics that show exactly why we should be prioritizing web performance in our applications. First one, sites that load in 1 second have conversion rates that are 3 times higher than sites that load in 5 seconds. Going off of that, bounce rates increase by 123% if a site takes longer than 1 second to load. I think this last one kind of ties in exactly why we should be really prioritizing this. Websites that load slowly cost retailers $2.6 billion, or US dollars in sales each year. I think these statistics paint a clear picture of why we should be prioritizing web performance, but today I want to talk about how our framework's solving web performance. Today we're going to be looking at 3 different buckets that these frameworks are attacking in order to improve web performance. 3 I'm going to talk about is rendering, hydration, and deliverability. And we're going to look at these advancements that these frameworks are taking in order to solve these 3 issues. Starting, of course, with rendering. In the traditional sense, you saw 2 different rendering models. You either had, which caused our clients to have 2 different problems. They're either waiting on each individual page in a multi-page application, or they're waiting a longer time for that first page to load in a single page application. With these new advancements, we're seeing a different change. We're seeing integrations and combinations of different models in order to render these websites. So we're taking the best of both worlds in order to increase the performance. So the first area we're talking about is React and React server components. So in this example, we're going to look at your normal e-commerce website. You know, you go to your Amazons, you go to whatever you may picture. You have a product grid, and then you have your interactable components. You're going to have an add to cart button and maybe a stock availability that shows you real time how much stock is left. When we have React server components, we're going to be taking these pieces of our page that the clients only need to see. They're not going to be interacting with, and we're allowing that to be rendered on the server. We're allowing the server to compile this and create an HTML page that gets sent directly to our clients with this React server components. And you might ask, well, why don't we do the whole page like that? Well, you have to think about the interactable pieces. We still have to compile the event listeners in the browsers. We still have to compile the real-time state management in the browser. So the interactive pieces we're leaving on the client to render, but these pieces that the clients are only going to be looking at, we can use React server components. A thing that ties this together is React Suspense. Suspense allows us to render these components on the server and still have a space that says, hey, you're going to get a component, it's just not here just yet. It's allowing us to have this state and shows a placeholder while these RSCs are still loading on the back end. So the server handles the heavy lifting, client handles interactivity, and Suspense keeps perceived performance high. Second area, and this ties in closely with RSCs, but Next.js streaming SSR. In traditional sense, you often see a blank page. You'll see a blank page while these components are loading, and then you'll see the entire page load all at once. When we are able to stream these, or stream SSR, or server-side rendering, we're able to stream these components to the front end as they finish. So we're no longer waiting for all of the components to finish. We're telling Next, hey, when this is done rendering, you can send it to the front end. So we're no longer waiting for these heavier components like the products or any component that's going to be heavier. It won't hold up something that renders much faster, like a header or a sidebar or all these other elements. So we're no longer blocking the rest of the components and have components waiting ready to be sent to the client. We're able to stream these components to the client whenever they are finished. And third is Remix. So this is a little more hands-on. So in this example, we have a dashboard, and you'll see on the top left, we have the file structure for this dashboard. You'll see we have a dashboard component, the JSX, but we also have a dashboard folder. In this Remix, we're able to, or they're recognized as the exact same component. It understands that this folder is talking about the dashboard component. And within the dashboard folder, we have these nested routes where you can put whatever other components you want in here, whether it's sales or any other dashboard you want. And when we navigate to /dashboard, we'll have the dashboard component. This will be your layout, but within this layout, you will have an outlet. This outlet is a place that holds these nested routes and nested components. So the big part of this, when you navigate to dashboard.sales, you'll see the sales component is in there, but here's the best part. This is why this is important for rendering. The dashboard doesn't reload. In a normal component, this whole component would have to reload. It would have to figure out the parent, and it would have to figure out the child. But in this instance, only the sales part reloads. So we're only changing the page when a component changes. We're able to keep the state that stays the same. So why do we talk about rendering? And what direction are these frameworks going? Well, we're seeing that instead of having this hard set, you're either all in on SSR or client side or server side, we're mixing the best of both worlds. We're able to get these hybrid approaches in order to get the best experience out of our frameworks. Now, the next area I want to talk about is smart hydration. This is when our HTML becomes interactive. And in this case, this can cause performance delays on the front end because we're having to wait for all the interactivity to be resolved on the front end before the users can actually interact with our page. And we're going to see exactly what these frameworks are doing to allow our users to not be blocked by the other interactive components, but be able to interact with our page faster. And I'm not skipping Astro, I promise. So the first area is Astro Island architecture. So obviously we have our static components. In this example, it's a blog page. Our blog content's not going to change, so this static HTML is sent to our client immediately. But our interactive components, our search bars, our comment section, things that need to be hydrated and need to have interactivity are going to have these slots called islands. On islands, we have these on the front end, and these are going to be placeholders until these interactive pieces are fully hydrated and able to be interacted with from the client. So our static HTML gets sent to the client as quickly as possible while still not hindering our site by removing the interactivity. The interactive pieces come later, but we're getting content to the client as quickly as possible. Second area. This is a fun one. I like this one. Quick resumability. So when we have a traditional site, on the server, when we think of server-side rendering, you think it plays through the logic of the site. We get the state management, we get the event listers on the server, and it just gets sent to the client. Well, the client also has to replay all of that logic. It has to determine that logic by itself because of all of those interactive pieces. What does Quick allow us to do? Quick allows us to serialize this app's state, the componentry, the event listers, everything that makes this app interactive. We're able to pause it at that state, send that in a serialized version to the front end to the client, and the client resumes this status on the client. So instead of having to replay this logic on our client side as well as the server, the client just continues on like nothing, like it had done it itself. And you think about a video game. Has anyone been playing Silksong? A couple? Okay. So if I would hate the game if I had to leave and I just paused, left, and restarted from the very beginning when I came back. I would never finish it. But since we're able to stop, save, and come back to that same state, that's what makes the game finishable. And this is what Quick is doing. We're pausing that state and not replaying it from the beginning. On the client side, we're able to resume from that point. And lastly, Vue.js lazy hydration. I'm going to hurt a lot of y'all's feelings with this. Sometimes we make really amazing components. You put all of your work, you spend like a week's worth of dev hours building this amazing interactive component, and the users are just going to skip over it. The users are going to navigate off of the page, or they're going to go to a different sidebar or a different link before they even see this component. But the truth is that component still hinders the page speed. That component is still going to hold back how fast the clients are able to interact with their page. So what does Vue let us do? In lazy hydration, these components only hydrate when they absolutely need to. When they come into the viewport or they're interacted with, they will not hydrate until the client absolutely has to have it hydrate, until they have to interact with it. So what are we seeing? With these different approaches, we're seeing the priority to get interactive client as quickly as possible. We're not rendering, or we're not hydrating everything all up front. We're choosing, or these frameworks are choosing to hydrate at proper times when it's absolutely needed and as quickly as possible. We're not blocking anything with our hydration techniques. And lastly, smart delivery. We've seen, and I'll get into this a little bit with the Astro, with the Astro section in here, but when we deliver our apps, a lot of the time there is bloat. There is unnecessary JavaScript that the client's not even going to use on the client, or the client's not even going to use in the finished product with the end users interacting with it. So how do we prioritize and ship less to our, or how do we smartly deliver our apps to our clients? Well, the first area is Next.js and NextScript. NextScript allows us to decide and prioritize when our script should be loaded in our site. And we have 3 different states that we look at. Before interactive, that's our top priority. These are the scripts that we absolutely need on our site. That's going to get loaded before any hydration. After interactive, it's loaded after hydration has started. We're already going to start making this site interactive before we even start loading these scripts. And lastly, lazy on load. It is loaded during idle time. Our app is completely rendered, it is hydrated. We're going to wait to render this until it is idle. We're not rendering anything else or hydrating anything else on our page. And that can be our, or whatever third-party scripts that you're choosing to prioritize, that's up to you, and that's up to what your page actually needs instead of being forced to load all these scripts up front and hinder the page. Now, second area is Astro. So other frameworks, like I said, send a lot of bloat. By default, they're going to send JavaScript to the client. And a lot of the time, the client's not going to use this JavaScript or is going to provide extra bloat and increase that payload, making the deliverability to our app, or hindering the deliverability to our app. Astro changed that mindset. Astro said that we're not sending JavaScript to the client by a default. So instead of other frameworks asking, what can we strip away to make this deliverability faster, Astro is saying, what do we need to add that's absolutely necessary for our page? Making a priority for minimalism as we're sending these payloads to our client and making sure that it's only delivering what is absolutely necessary. And last, we were talking about Nux, Nitro and Edge. So Nitro is Nux's new server engine, and instead of relying directly on Node.js servers, Nux can now be run on any environment, serverless, Edge runtimes, workers, and more. So now we have the capability to bring Nux apps closer to our clients and where our users are living. Now, I know what you're saying, Caleb, this is cheating, this is DevOps. But I want to paint the priority that as a default, Nux is giving us that priority and the advantage of having the ability to host these on Edge runtimes. That's at the framework level as a priority. We're not over-configuring, we're not having to specialize our app to be run on the Edge runtimes, but Nux as a default is prioritizing hosting our apps closer to our users. So why did I talk about deliverability? The truth is that even if our hydration and our rendering is spot on, completely optimized, delivering the apps is going to be the advantage that we take. That takes our app to the next level for delivering these sites to our clients. So 3 core areas: smart rendering, smart hydration, and smart delivery. We've seen these 3 big bottlenecks that have been in the industry for a very long time, but we're seeing a shift in the mindset of these frameworks. We're no longer seeing a battle over which way to write, server-side, client-side. We're not seeing this fight anymore. We're seeing an agreement and kind of a compilation of what is the right method for these sites to actually deliver our app in an efficient way. And that's a big takeaway I want you to take from this talk. It's no longer about what frameworks are the best or what frameworks are the fastest. It is these mindsets in these core areas that each of these frameworks are attacking in a different way, that as developers we can continue and push forward and think about these mindsets and think about facing these bottlenecks as we build these sites that are going to bring our apps from building in the past way to building our apps in the future. And that is the true way that we face this need for speed. Thank you. I have a little extra time, so wow. Hi, guys. So I have a little extra time, so this is a QR code to my LinkedIn if you want to send me a connection. It has my website on there, a little bit of extra information about me. I forgot I just threw a QR code up there without actually describing what it is. So yeah, that's a QR code. I would love to connect with you. obviously, you can feel free to connect with me after. We can ask questions. We have lunch after this. I'm very excited about lunch. I'm very hungry. But yeah, I just wanted to thank all of you for attending the talk, and huge thank you to CYC and everyone who made this possible in general. Can we give a round of applause for everyone? What this community is doing and what this conference does for the community as a whole, I've seen so many people fly into some amazing locations. It is such an amazing opportunity, so I just wanted to put that out there while I have some extra time. But thank you all for listening to my talk here. I really appreciate everyone who made it out, so that is all.
Hi, everyone. My name is Hermes Frangoutis. I'm Director of Developer Relations at Agora, and over the past year, I've built a number of different voice agents using Agora, OpenAI, 11 Labs, Cerebras, Pinecone, a bunch of different really cool technologies, and I'm here to share with you 10 of the coolest lessons I learned and things that helped me along the way. So each project was kind of an experiment. Some worked out really well, some broke in really hilarious ways. And every single one of them taught me something that I couldn't have learned from just looking it up online. So here's 10 lessons I kind of learned the hard way. For anyone not aware who Agora is, we are early pioneers in the real-time voice and video streaming space. We specialize in voice and video streaming infrastructure, so one-to-one, one-to-many, many-to-many, that sort of thing. If you want to have Google or Zoom or that sort of features in your app, that's what we do for you. But one of the things that we realized is while our platform is really good for human-to-human interaction, it's actually even better for human-to-AI interaction, where every packet has to make it. And if it doesn't, the conversation can go in a wildly different direction when it's misunderstood. So voice agents are, they're deceptively simple. You know, you think plug in the speech to text, add an LLM, get the text to speech, and we're done. It just works, right? Not really. And what I discovered is they're easy to build, but really hard to scale. So let me show you why. Before we get started, I do want to talk a little bit about visualizing what I call a cascading flow. So in voice AI, you have two models, an all-in-one and a cascading. All-in-one is just like the name says. I speak voice, audio comes out. A cascading breaks all those little pieces up. So you have your speech to text, and then it passes the data to your LLM then passes it to your text to speech. And this whole flow, Agora can do in about 650 milliseconds. So a little over half a second, but it gives you a really natural language and communication when you're speaking to an AI. So here's how it started. Back in October 2024, I know it's not 2025, but this was when OpenAI released their first beta of their real-time API. And the team, we were building different demos, and we built an integration where each of these like blue dots basically represents a server instance. Each server instance could handle 3 or 4 users when they activate the agent or talking to it. Because unlike a traditional LLM, when this agent's talking to you, it's got to stay in the conversation. So it's not just responding and then leaving. So when it starts, you have to also be interacting with the same server instance to take it down, to turn it off. And one of the things we realized is a traditional like load balancer, router, gateway wasn't going to work because they just load balance differently through like round robin and things like that, but your start and stop requests would not be going to the same server. So when deploying something like this, you have to have multiple servers. You have to have this load balancer. So we had to build in our own custom little load balancer to make sure that all the start and stop requests went to the right instances and the right agents were leaving. And in that process, something I noticed that people at the time were telling me I was crazy, but recently one of the VPs of research from DeepGram confirmed it. The voice out is not always equal to the text out. So like in JavaScript, you know, you have the triple equal sign. It's not even a double equal sign on this one. Like the text is just different to the point where you can't trust it, and it's so black box and like because it's a voice to voice. So that was a very interesting takeaway. It's like, all right, I'm hearing this audio, but I'm getting different text in the transcript, which doesn't really work if you're trying to audit these things later on. Like wait, we have 2 different things that don't reconcile, and the user's experiencing 2 different things. So after that, one of the next projects I got to build was with Agora's conversational AI engine. I got an early preview of it in February, and the really cool thing is all I had to do was build the front end. Like to get started, I pulled up the voice demo from Agora, plugged in my details, like the app ID and token, and then used just like a curl request to invite this thing into the channel, and it just starts talking to you. I didn't set up any infrastructure. I didn't set up anything other than this like post request to the back end, which was really cool. So from there, I then built a whole UI where like it shows you the visuals and stuff like that. And this was kind of like my first end-to-end agent, and it was really, really amazing to see the cascading flow and how much faster it was than the OpenAI like all-in-one. Because the OpenAI one was using like WebSockets, and this used UDP. So in terms of the data transmission, you didn't have all those handshakes and the checks to make sure that the data came back. The reason I bring up WebSockets and UDP and stuff like that is because my next project that I got to work on was mid-February, 11 Labs had a hackathon where they had just released their conversational AI, and they were getting people to like build with it. And I thought, man, this is really cool. Looking at their API, it had similar WebSocket type interface to the stuff we had just done with OpenAI. And I was like, all right, I could do this. Sat by myself for a weekend in their New York office, basically taking the Python demo that we had for Agora and OpenAI and rewriting it to work with the 11 Labs interface. Load balancers, everything still had to be the same because at the time they didn't have a WebRTC interface, so it was all WebSockets. I deploy this thing, and one of the things I realize is they're using a cascading model. It's not all in one. So as I'm talking to it, there's like visible delay, like lag in the time that it's speaking, and sometimes it'll like pause and then like keep speaking. It was very interesting to say the least. And what it made me realize is like WebSockets can't be part of the equation. They're just too laggy in that sense of communication. There's too much checks and like, oh, did you get that? Nope. Let me retransmit from the beginning, right? Whereas UDP, you just drop the frames. In general, it was like a really interesting project. I really learned that latency and flow matter. One of the things, because it was a hackathon, I didn't get to put the interruption detection in there. So I'd talk to it, I'd ask it a question, and just start talking. It's like your 3-year-old when you ask them a question, they're blah, 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 and you can't even like respond. That's kind of what it felt like. It was very interesting, and it made me really appreciate the fact that we have that turn detection. So my next agent project really came about as more of like a fun thing. So as I'm building these agents, testing Agora stuff, like my kids are coming into my office because I work from home, and they see me talking to the computer. First, they thought it was hilarious. Then they started talking to the computer, and I was like, man, this is not safe. Like the interface is really frictionless, but you can't just let a child talk to an AI like unfiltered. So I'm talking to a buddy of mine who's also real big into AI, and he's liking the voice stuff. It's like, wouldn't it be cool if we just had a voice-to-voice AI that had some like simple guardrails on it, and you could hand the phone to your kid? So in a weekend, we built the UI, and because it's running on Agora conversational AI, there's no back-end infrastructure that I have to launch, and this thing is awesome. After dinner, I'm like, hey, finish your dinner, you talk to Beepo for 20 minutes. And they just ask it all sorts of wild questions. They'll even ask it, hey, make me a story about a carrot, a broccoli, and a chicken. And the thing will just pick up and go, and you can interact with it. It's really cool. I'm going to try to do a demo of Beepo probably at the end. So let me get through. But the one big lesson I learned here is the prompt makes all the difference, and use AI to help you generate the prompt. Because I noticed that the prompt that I got out of OpenAI is almost impossible to jailbreak. Like some of my coworkers were playing with this thing for 2 hours, trying to get it to like say inappropriate stuff and speak about inappropriate things, and they just couldn't get it because of that prompt. And I realized how strong a difference the prompt makes. The next project came in May. We're doing a product video for Agora's conversational AI engine, but it's all code. And so you can't really show a screen of like me typing code and stuff. Like it doesn't come across as very interesting. So taking some inspiration from 11 Labs, I saw their UI for their conversational AI, and I was like, I could rebuild this all with Agora technology. Thank you, V0, for the UI. But yeah, so you log in, you can click create a new agent, and basically it stores this data in JSON. So when you hit test, it sends it over to the API endpoint, triggering that agent. And it was really fun because we could switch between agents and different prompts, and you could really show the flexibility of it between, here, this is what it sounds like with this TTS and that STT provider, and you could really customize and play around. I also included Agora's cloud recording for the audio recordings and our real-time transcription, thinking, you know, if you're testing these things out, it'd be great to have an audit of it, because like every conversation, it's really hard to track, especially if you're finding bugs, right? Like you need to know the agent ID, you need to know all these details because these things are done at hyperscale. So it's like finding a needle in a haystack. And it was a fun little project. It took me about a month. And what I got out of it is, it's really cool to see all these agents and like being able to customize them. But when you go straight to the model like this, it doesn't really do anything other than talk back. So my next project was to build an agent that could do something, right? And I travel a lot, so I was thinking it'd be really cool if I could have a conversational AI that was like my local guide. I was like, all right, let's start with a long context. I travel a lot to San Francisco, so I used the Yelp API, pulled down a bunch of restaurant details about restaurants in San Francisco, put it into a JSON, and then included that JSON as part of the prompt. Interestingly enough, it completely hallucinated most of the data in there. The longer the prompt, the more likely the AI is to hallucinate like what you're expecting. So that was kind of a bummer, because it was like, oh man, if I could just like stuff it all into the context window, Google Gemini, we're great. Not so simple. So taking this one to the next level, create a new endpoint, did it with RAG. Using Pinecone, stored all the data in a vector DB, had my own LLM in there, so as the data came through, I sent it to Pinecone first, got the relevant restaurant information, then passed that all to the LLM. Boy, was that good. That was really responsive, it was really good, really accurate on the data. Problem was, all I had was San Francisco. So like, the RAG is only as good as the data you can hold in it. It's not like live data, so you constantly have to update the RAG and maintain the RAG, and that's kind of a bummer. So going back to the drawing board, next time around, I'm like, all right, rather than RAG, we're gonna go straight to the API. So using their API, I wrapped it in some functions, started doing function calling. Very interestingly, you cannot use text streaming when using function calling. You have to use full response, because as it's streaming out, it has to know what the function call is to be able to trigger it. Some of the newer models are better at this, but at the time, I was using Cerebras, and it just wouldn't allow me. So that was kind of a bummer, because you don't get that really cool stream effect. Like, there's visible delays in this thing's taking all the output, sending it to the model, executing a function. And that was the other fun part. After you execute the function, you can't just pass back the response to the user. Like, I don't need to see a JSON. I need to hear natural response. So then it got into, oh, all right, when you do a function call, now you have to reprompt before you return. So you take the response from the function call and you put it into the context and then just send it right back to the LLM. And that was quite amazing. I was like, whoa, this is cool, because you could ask it for like, what's the best pizza in Morristown, New Jersey, which is where I'm from, and it would give me a place. I'm like, I don't know if that's really that good, but according to Yelp, it's great. So, huh? Yeah, we need an update there. So, a couple learnings. You know, streaming doesn't work with the function calling. The output from your function call needs to be reprompted, and then the prompts really must be clear. Because one of the things I noticed is, like, if you don't have really good examples of what those function call structures look like, it'll hallucinate the function call, and then it'll repeat that back to you. So you get like, I don't even know how to describe the response. It's like hilariously bad. It's like trying to read a function out. So it's interesting when it malforms. And like, I've heard of this before, like certain models are better at function calling. Like, and I didn't understand what that meant. What that means is when it tries to put out what it needs to trigger the function call, it doesn't get that request right. And so it doesn't actually call the function, it just tells you what it thinks it should have done. So now that I had a Yelp agent that could look up data for me, that's cool, right? But doesn't really do much more than be a useful kind of assistant, which is the same as just talking to it. So my next project was, how can I get this thing to order me dinner? And that was an interesting one. I was like, we have this PSTN technology. For anyone that's not familiar, PSTN is how you connect traditional telephones to voice over IP and like real-time streams and stuff like that. So some of our team members had built a PSTN server that I was able to tap into and use their phone number. So using, again, just a RESTful API call, I could trigger another bot that dials out. So using this, I was triggering phone calls within the same chat. I'd be like, here, order me dinner from this place. This is what I want. Make it pick up. The connection would join. I could see the other voice in the chat. I could hear myself because I was calling myself. But funny enough, the AI would look at that as a new person and just start over fresh. Be like, hey, how can I help you? And it's like, well, you called me. How can I help you, right? Yeah, exactly. And then you go, but you called me. How can I help you? Oh, I think there must be some confusion. I'm your local friendly AI guide. And it's like, wait, that's not what a restaurant should be hearing, right? So that's very off-putting for the person. So thinking about the solution, I was like, how can we adjust it? Tried doing it through the prompt, kept going terribly wrong. In some instances, it would like start well, but then the person would speak, or I would speak. It'd like catch both the audios. It was very awkward. So the revelation, I guess, or what I've found out as a solution is multi-agent. So I have one agent. They control the ability to get all the order, collect all the details they need to. But then I wrote a function call that uses Agora Conversational AI that makes a post request. So no backend, like I can launch infinite ones of these. And in that second agent, it's part of their system prompt what I want to order. You're this agent, you're calling this place, you're ordering this food for so-and-so, pickup, delivery, whatever, has all the details right there. So when it would call, it'd be like, hello, so-and-so pizza. Hey, I'm placing an order for delivery. Okay, what's the name? This is for so-and-so. Where's it going? And it would actually respond. I shared this demo internally. Funny enough, I forgot to take my phone number out of there. So I had at 4 a.m., I can probably see it still, a bunch of voicemails from an AI agent that are just like 30 seconds to 3 minutes long of it speaking orders to me. So that's another lesson I learned the hard way is if you are using PSTN, do not hard code your phone number into the demo. So if you'd like to try the Agora Conversational AI engine demo, here's a quick link. Give you guys a couple seconds, take some photos. I got some more QR codes, so we'll keep going. Cool. All right. Nice. All right, next one. So if you want to start building, here's some more examples, quick start guide, that sort of thing. And while you guys are doing that, I'll spin up Beepo. So let's see if we get this rolling. Sorry, the PWA is not being friendly. Let's see if the Wi-Fi lets me do it here. Sorry, guys. Looks like my Beepo demo is not working. And the Wi-Fi is not happy with me. So if you want to see Beepo, I will gladly demo it after. I have about 5 minutes left. I know we're not really allowed Q&A, so I do want to thank everyone for their time. Cool.
Test, test. Okay. Nah, you're good. It looks like I wasn't gonna get it anyways. Somewhat. No, it'll be positive. It'll be positive. Are you pro or anti? No, that doesn't work. Well, are we set to go?
Yeah, we are all set to go. You can start 1:30.
All right, cool. Y'all shut up now. All right. All right. Just want to get everyone's attention. Okay, so every day we're being lied to about AI by some of the most influential and who are supposed to be some of the most trusted people in the industry. We see it all the time. A writer trying to get more views, or a YouTuber on some kind of video, they want clicks. AI company's CEO wants to get into the news, so they say something completely outrageous. There's a lot of headlines out there, and the internet has no shortage of these. A lot of people that either have no clue what they're talking about or have some ulterior motive. And you ever notice that anytime someone says something like this, like coding is dead, we're all going to be replaced by AI, is weirdly selling the solution to the problem, right? You create the problem, you sell the solution. And this is why everything that we see on the internet, we have to take with a grain of salt. Like the late and great Abraham Lincoln once said, don't believe everything you read on the internet. So true. So I've had the honor of a lifetime over the past 6 years teaching tens of thousands of developers, mostly online, and where I used to have an inbox filled with messages about career updates, celebratory messages, questions about technical advice. Now my inbox is filled with questions of fear, doubt, and uncertainty. I don't know what to do. Is it still worth learning this? Am I learning the wrong thing? These messages come from real people with families whose lives are being disrupted. Many have dedicated countless hours, time away from their family, pouring their time into something that they don't know is even going to exist when they finally complete that journey. A lot of people will quit this journey. Some will never even start pursuing something that can change the course of their family's future. This kind of stuff pushes them away. And every time they see a headline like this, it's like a gut punch. And to the people that never start, I get it. Why would you want to go into an industry, do one of the hardest things that you'll have to do in your life? I think anybody here who's been through that process in the early phase understands how difficult this can be. And they just leave it. So I take these headlines personally. Now, AI came with a promise of enhancing our capabilities. It was supposed to make us better, allow us to focus on the things that we're good at, do more. But lately, it's been more of a nightmare to so many. Now, for me personally, I still believe in the promise of AI. I've seen a lot of the good that can come out from it, and I've seen how it can change things. So I'm very hopeful about this. And with this, to combat something like this, I believe the solution is to get educated. To simply know. When you don't understand, when you're starting this journey and you see the CEO of one of the biggest tech companies in the world say something like, don't learn to code, how is a beginner supposed to deal with that? Or someone that maybe isn't actively out in the field and doesn't know what's going on, how are you supposed to cope with messages like this? So my hope is to maybe provide a little bit of insight. I want to explain how I use it, how I've actually adopted it, and if you haven't even touched it, hopefully see how it's actually implemented, and it's not this robot that's coming after us like a Terminator to come get us. It's not that. It's actually much more tangible. So the first truth is that AI is here to stay. For those of you or anybody here who thinks it's going to go away and you're just burying your head in the sand and you just want it to return back to normal, that's not going to happen. If there's any constant in life, we understand that things will always adapt. We've seen this evolution from the late 90s to where we're at now. Things have always changed. Now, we've had hype cycles where it wasn't exactly what people said it was, but they do change. Now, I also don't believe that this is one of those things where you have to adopt or you're left behind. I don't believe that that's the case because that's too broad of a statement. There are a lot of industries where we have companies that haven't even adopted to 2020 standards. They're still on old tech, legacy code. So to say that everyone has to adopt doesn't make sense. A lot of us are working on code that's old. It also affects every industry differently, but I do want to say this. If you want to work for innovative tech, you want to work at the tech companies that are on the forefront of doing stuff right now, this is probably going to be adapted in one way or another. We use it internally for code reviews. We're creating systems and processes to start using this in our company. I'm seeing it, and I see a lot of people actually adopt it, and beyond the hype, I actually see how it works, and I think it's pretty cool. I'm going to pause right there, actually. So with this, there's also a level that we want to implement AI, and we don't want to adopt everything right away. So for me, I'm also very skeptical about bringing this on board. There's a lot of stuff where we learn throughout the process of building, right? The bugs that we face, the ones that we hate the most, when we have to spend hours thinking that we're going to solve this issue in a couple of minutes, and then we go down these rabbit trails, and we have to find all these other solutions to issues we didn't even know we had. By the time we solve that one problem, we learn so much, and later on, those become the biggest blessings in our career. So stuff like that, I'm not willing to offload to AI. I like going through that, so to me, I'm going to adopt it very slowly. And to be safe with that, to not rely on it too much, I've adopted a process. So I'm going to give you 3 levels of which I use here. The first one is the tutor. I think all of us know this mode. This is where AI is now starting to teach us. We use it to search, we look things up, and we're able to speed up the process. We're able to ask questions that are more direct to us. Now we don't have to go to Stack Overflow and hope somebody had the same exact issue 4 years ago, and then when we do see the issue, only to find no one replied to it. It's a little bit annoying. So AI for that has been amazing. Use it as a tutor to help you out. Now, what's one of the problems with AI giving us advice? Anybody? Yes. AI hallucinates, and I've seen it give me some bad examples. It's like a friend who wants to give you the answer, and if they don't know it, they're just going to answer very confidently, and it's going to sound real. You're right. Exactly. How to make cheese stick to pizza. I don't know if this is true or not, but this went viral. And allegedly, the response was add 1/8 of a cup of non-toxic glue and mix it for tackiness. We got to be careful for this. It's up to us to know how much we trust it. So when I say use it, you obviously have to be mature enough to know how to adopt it and not trust it like an all-knowing being, because the more you use it, the more you realize it kind of doesn't know what it's talking about. It's good at summarizing, it's good at collecting information, but we can't go all the way. Now, level 2, tab complete. This was something that I only started using about 8 months ago. I never adopted Copilot. I thought it was like autocomplete in your email, where you start writing and it tries to complete the sentence. I didn't like that because half the time I didn't like the way it would format it. I talk a certain way, and I like that to be expressed in my emails. So I pushed this off, and then my boss one day messaged me, and he says, Dennis, have you tried Cursor before? I said, no. He says, Dennis, there's life before Cursor, and there's life after Cursor. So I had to try it, and I was hooked like that. Tab Complete was so much more than just autocomplete. It knows your code base. It's actually very smart. And it worked, and again, speed and productivity. It enhanced my life, things that I've done 1,000 times, writing my API endpoints, stuff that I'm willing to offload. I was able to use Cursor, but there was another issue with this, or I was able to use Tab Complete. But the problem with this was that I found myself more likely to hit Tab when I'm coding than to actually review my code. See, in the beginning, I didn't trust it. I'm very skeptical. I'm one of those old adopter, or I'm not an early adopter, I guess that's probably the better way to say it. So I don't trust it, so every time I would write code, I would review it, and then I found myself getting lazy. I would just hit tab, 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 and then I got into code bases that I wasn't so familiar with, or I was working on a feature that I haven't created before, and I found myself hitting tab, not knowing it. Then when it wouldn't give me the answer that I wanted, I would get irritated. See, I was used to getting a bug in my code, getting a cup of coffee, cracking my knuckles, and figuring this out, and using this as a learning opportunity, and I found myself getting irritable and not wanting to do that anymore. So my solution to this was to turn it off anytime I face that. If it's code that I need to know, if it's not something that I'm building for a demo I'm trying to crank out, I have to turn that off and I take off the training wheels. It can get dangerous. Now, level 3, this is agent mode. This is what you see all the controversy about. This is where AI is actually writing our code for us. And this to me is one of the more exciting parts, but there are two sides to this in my eyes. There's the vibe coding part, which I believe is being misinterpreted, and everyone has their own idea of what vibe coding is. And then there's coding with AI. With, that's a keyword. Agentic coding, whatever we call it. I don't know what the official term is. Now, vibe coding is where we are, by official definitions, because I know people say coding with AI, they just use vibe coding interchangeably, but it's giving into the vibes, embracing exponentials, and forgetting the code even exists. There is actually a place for this. I've used this before. For me, it's in building prototypes, building demos, testing features. I've spent weekends before trying to build an idea, only to set up all the boilerplate, and then to find out it's not really that good of an idea, and I throw it away and I waste time. For this, I build quite a bit now. It's a lot of fun. You're able to crank those out, and I think it's amazing. It's amazing for internal tools. I built myself a read time calculator. I have to test the time of my speeches. I want to make sure it's within a certain time. There are some online, but I like it to read back to me. So I built myself a read time calculator with a couple of prompts, added in voice AI, and I have it read back to me. Internal tools like that, things that you aren't pushing out to the world, I think it's amazing for that as well. Now, there are going to be some cases where people will create something cool, but this is not what the future is, and it's not what's going to make you a billion-dollar app. If somebody wants to argue with me after, we can talk about that, but anybody that actually codes understands the limitations of this. The more you give it, the dumber it gets. You're not going to have non-developers replacing developers. I'm sorry. That's not the case. Now, the other side of this is coding with AI, and I didn't plan this out because I have an echo here. Let's see if I can stand here. Coding with AI is where we embrace it. Is there a bad echo? No, pretty good, okay. This is where we are using AI as a normal developer, but now we have an agent. This is our cursor interface. Every interface is going to look a little bit different. So in here, we have our code, we have our files. I put them on the right. We can use the agent to help us out. Now, how people start is typically by prompting the agent, and there's issues with this. And I think that's how we normally adapt it, because you're just new to this interface and you just want to get started. This method has a lot of downsides to it, because when you're prompting an agent and you're not giving it accurate instructions, it has limits and it goes off the rails. It's hard to document what you've done, what you're about to do. It's hard to track changes, and it's limited. And I see an issue with this when it comes to companies adopting this in big orgs, where you have to always have a track record. Everything has to be set and structured. I think it's limited to that. Where I do see people adopting it is in creating good processes. Now, for me, I did some research and I wanted to see how companies are actually using this. And I saw a couple of processes that I like, and I saw an example that I wanted to show here that summarizes one of the simplest versions of this. And this is in adding a new feature. Now, if you're working internally, prompt the agent, do your thing. But typically when you want to add a new feature, what do? In a company, you create a task for it. You create some kind of ticket, a PRD, product requirements document, and this outlines what the feature is going to be. So first, you start with that. So in this system, if I want to tell my agent to build something here, so we're going to do a quick example, I have a create PRD template. So instead of having to prompt my agent to create me a product requirement document, I already have a guideline. Here, I tell it exactly how to create one. I tell it once you make it, go ahead and create a file called tasks, or a folder called tasks, throw it into the file, and this is where everything is output to. So we're going to use a simple example. I'm going to have to switch between this example and then some code that I have complete, because sometimes it takes a little bit for the agent to do this. So we're just going to go into my files, and I'm going to go to the create PRD template. And we'll just say, build me a simple contact form, no backend. So we reference the PRD, and it already knows that before it's going to do this, before it actually starts the process, it's going to use that file, it's going to look into it, and now it's generating that. So it's going to ask me a bunch of questions, just like you would on a real team. What design are we using? What are the form fields? What exactly are all the edge cases that we're going to face? And it asks me a bunch of questions. Now, in this case, I don't want to talk to it, so I'm going to say, you do you, boo. And it'll create something. So here, from my create PRD template, this is what the output's going to look like. It's going to give me a folder called tasks, and I have a final PRD. So here we see the goal summarized, a full overview of what's happening, all the details we want to add to it, and so on. So if I like it, it looks good, we go ahead and approve it to the next step. So we're creating a slower process, but one that can be repeated. see how long this takes. Okay, so while it's doing that, in the next step, what do? We have the PRD. Now we want to create an execution plan. We want to go ahead and put this into action. So for this, I have a generate tasks file here. And here, we're going to take the PRD, and we're going to create a set of tasks, an execution plan based on that. Again, I don't have to create this from scratch. I reference this. Here, it knows once a PRD is provided, now create a tasks dash and then the feature name, and also output this here. And we tell it, OK, we want to create tasks. We want to create checkboxes. Do not allow a user to proceed with the next task until one is done. If everything works well, we can move on to the next step. So how to implement this? Go here. So it looks like it created that. Now, that was a demo. It's almost done. There we go. OK. So now we have our PRD. This is the one we just created. We'll accept all. See, this is much better than blindly accepting it and trusting it to figure things out. Now I can see if it made a mistake, if it didn't understand me, I can see it in the PRD right here. So we're just going to tag the PRD here. So that's in, actually, we're going to do generate tasks, files and folders, generate tasks, and we'll just say create a task list. And we're going to go ahead and grab our PRD here, and we're saying use this template to generate a task list from this PRD. And we go through the same process. Now, again, it's going to take some time, so I have the complete version. It's going to generate something like this. I see all the files it's going to create. I can call it out when it's run. I can see the exact task that it's going to follow in order to complete this. So once this is done, I have another template called process task list. And this right here tells it to follow that task list line, or the task list folder. So you notice we're stacking it on top of each other. So now we're referencing the list of tasks, and we're saying go ahead and do this. Here I give it a list of commands it can run, all the rules it has, don't move on to the next one until I review it, and so on. So these templates right here allow me to create this process. And this is how I've seen bigger companies start adopting it. Now, I've seen systems that are much more complex than this. I've seen these files just for the front end, just for their APIs, and then with them a set of rules for design. How do you know what the AI is going to create when it comes to your buttons, cards you want to create on your website? You can have these systems in place and plug those in simply by tagging them. This is what I see as the future of AI development. I don't see it as vibe coding. I see it as using this as a tool and properly implementing it. Now, I want to end with a few things here. First of all, for any junior devs, anybody that's just learning or getting started, your job might be affected in a few ways, but the task of learning to code does not change. That's one thing I want to make clear. This isn't going to be a future where people are going to come in and just prompt and build stuff. No one's going to trust you to review these documents. No one's going to trust you to write code if you don't know how to do it. So that's the first thing, is continue on that path. Learn the basics. Don't over-rely. Maybe level 1 where you're using AI to search or do research, that's great. But that doesn't change. How you implement it, now this is going to be interesting. My personal opinion, I was just dogging on people that have opinions publicly. I'm a talking head as well here now. I think people are going to adopt this by having juniors more capable. I think juniors will be watching these reviews, implementing these, and I think we're leveling up. I think the junior is going to be much more flexible and in charge of more. There's no such thing as a junior role going away. At some point, someone has to start from the beginning, right? We can't just outgrow and then have no developers. So the way that you're going to be involved in this task is going to change. Internally, at my company, AppWrite, we use CodeRabbit for code reviews. Whether someone comes in as a junior, senior, or mid-level developer, they now have to know about these tools just like you have to know about GitHub. There's a lot of tools that you onboard with, and you have to start implementing them. So that's how I'm seeing AI integrated into the workforce. Now, as far as the future developer, we've seen some history go by already with frameworks being adopted, development going from hand coding everything to no-code tools. And every single time, it seemed like we were done. Yet when the low-code and no-code movement came around, it only added more developers. It democratized the industry. Now an author can create a website. A mother crocheting some stuff at home can now create an e-commerce store and sell it. Anybody can access this. And yet it didn't affect us. We simply changed what we're building and the tools that we're working on. And this is what I'm seeing as the future of development here. With AI, I think the developer is now a Swiss Army knife. We now have more capability in our hands than any developer from the early 90s, the best developers that you've seen. They're probably still better than us because they don't have to rely on these tools, but we can do more when it comes to actually implementing them. They didn't have half of these resources. And that's what I think we're going to be doing. You're going to see smaller companies with smaller teams, micro SaaS developers making a lot of money with teams of 1, 2, 3, 4, reaching millions, where historically that would have taken so long to do. We've seen low code do this already, and I think we're reducing team size. So you think less developers, right? No, I think we're going to have more companies. More ideas are going to be built out, and that just basically spreads the field out. It's given us more power, and I think it's only adding more. And that's my take on AI development and what the future is going to look like. Thank you all. We still have time. Anyone want to ask questions? We still got time. I thought I was going to be short. I tried to rush that. No? Hermes? Yeah.
Do you have like a template for that?
Yeah. If you follow me on Twitter, I should have added this. I can post it. So I'll make sure it's posted, and I'll tag it on my Twitter. I'm at Dennis IVY11. So this is the template that I actually used was from Ryan Carson, I believe. I believe he was originally the founder of Treehouse. And I actually used his template, and it was the simplest one that I've seen, the 3-step template. Yeah, I'll make sure I post that, and I'll tag him too to give him credit.
Where do you put documentation like for front end or for API or for back end? Because these 3 steps are clear, but it still needs to know about how this feature was implemented before so that it can add one more feature to this. So where do you put it?
So I've seen people create a completely different folder for that, and they'll layer it just like their application. So when where you have your front end and your back end, let's say if they're in the same file structure or 2 separate folders, they will basically replicate their entire application structure with files like that. So you would have a template just for front end implementation, just for styles, and for each part of that code.
So when you run PRT, let's say,
You need to tag the right folder, yeah. Yes, yeah. Usually it starts knowing where you're at pretty well, but yeah, you're just tagging that because there are design systems that you want to use that are just relevant to front end, right? So that's a really good question. Yeah, the way I've seen it is literally creating like a copy of what you actually have and then referencing all that.
Which models have you seen performing better in planning versus like actual code execution?
I'm using.
You're using Sonnet Max.
Yeah, I just kind of leave that. Well, I use Sonnet. For this, I did Sonnet Max to hopefully, make it a little bit better. But that's what I've been sticking to. I'm actually. Grok? I have not tried it, actually. Yeah.
And OpenAI for planning.
Really? I'm still in that research phase of trying to go into that. And I think, by the way, that's actually a really good thing as far as like where people should be adopting. I think it's knowing what models do what. What models are good at coding, what models are good at reasoning, writing, and so on. I think that's going to be very beneficial for the future.
You said you were doing read time. You create a read time calculator and it reads back to you. What does that mean?
So it's a read time calculator. So it basically takes the characters in like let's say this speech was written out, right? I would paste in the text, and it tells me based on how a human talks, like the average speed of me speaking or reading. It tells me how long the speech will take. But I often like to hear my own words written out. I don't know if I'm dyslexic, but I have a hard time actually reading long strings of text. So I just listen back to it. So I use 11 Labs to get a voice AI agent to read what I wrote, and then I can listen to my speech and say, yeah, that sounds good, or it doesn't.
And then you repeat it.
I don't repeat it. I just know, okay, if I didn't like what it said or it sounded off, I just rewrite it and then play it again and listen to it. I do this with emails too, by the way. It's not that I'm bad at spelling. I just I'll repeat words or something like that. My eyes get lazy when I look at the screen, so before I send an email, I copy it, paste it, listen to it. Sounds good, I send it. Yeah, so it helps me with that. But small project, I've been doing a lot of stuff like that though. Yeah, but it would have taken a weekend to build, maybe a couple hours, but it was about 15 minutes of prompting, and I deployed it and I use it internally. Yep. All right. Yeah. CodeRabbit is one, just for code reviews. Yeah, CodeRabbit. Yeah. We use it. It's integrated. There's a lot of different integrations with it, but right now we use it internally with GitHub. So we don't allow it. Like it basically is like the first step in PR review. So that way, it hooks into it. Yeah, and just in the automatic deployment process. It helps flag those things that a developer would have to look through multiple times on their own. just helps make that quicker, and it's really good actually. Yep.
Okay, perfect.
We just need to turn
The laptop.
Yeah, and once you hook towards the speaker.
Okay.
I'm gonna start the timer.
Okay. So wait, turn it away? Okay, just for my notes. Wow. Oh, are we ready to go? Beautiful. All right, so hello everybody. Welcome to the talk. Yeah, welcome. Woo, that's it. Nice. So I gotta say, I really love being a developer, honestly, because I think being a developer is like being part of a really, really cool club. And it's a club where we may not have a secret handshake, but we do kind of have a secret saying, a slogan that we can say that you can say in almost any language, and you will know that somebody is a developer. Can anybody tell me what that is in 3, 2, 1? Hello world, amazing. But the question is, what comes after hello world? And that is what we're going to talk about in our talk today. My name is Andrew. You are here for Goodbye World, Hello Battlesnake. And I'm going to jump into things right away. So here is our talk agenda for today. We're going to be talking a little bit about the history of Hello World. We're going to be talking about the starter project pipeline, so kind of the process that most people are going through. We're going to be talking about where Battlesnake fits into that. And heck, you probably don't even know what Battlesnake is, so we should probably talk a little bit about that. And then I am going to pray to the demo snakes because I'm going to try and do live coding, and a lot of things are not working on this network, so I'm going to do it from a Wi-Fi hotspot. That's going to be awesome. And we're going to hope that we don't have this experience, but instead we have this experience. All right. And I mean, yeah, he's running out of a burning building, but he's saving the snakes, right? So that's good. All right, so a little bit about me. I'm a former classroom educator. I broke into tech about 5 years ago working for a company called Battlesnake. I've been a lot of places since, but I actually have always stayed in love with Battlesnake. I love it a lot. If you recognize that hat, you probably also recognize this meme. That is 100% me. But I also love learning. I really, really love learning, and I love it so much that I actually spent an entire kind of year doing a live stream series called Does It Toggle, where I kind of built out Hello World projects in any language that I could possibly find. So even there, I didn't actually even know what Hello World was all about, and so for this talk, I did a little bit of digging. And believe it or not, it's not actually Hello World, it's Hello Brian. And this is Brian. Brian is actually the person who popularized Hello World, and he worked for Bell Labs back in the 70s and 80s. He's also wrote one of the first books on the C programming language. But we're not here to learn about C. This is a JavaScript track. A way cooler JavaScript Hello World function is up there. And the Hello World actually came from Brian remembering a comic that he saw of a chick coming out of an egg saying Hello World in the caption. Also, fun fact, my good friend Brian, a fellow Canadian. And yeah, that's it. There we go. A fellow Canadian. So that's Hello World. That's where that came from. What comes after Hello World? What is that kind of progression pathway once you've gotten in? So first things first, we've got our Hello World. Then we kind of move forward, and a lot of you probably did this process of we built a calculator, right? Something like that. Then you probably went on to do some sort of a CRUD app, like a to-do app. And then you probably went on to do something like a game. And we'll use Flappy Bird just because I've seen a lot of AI models building Flappy Bird. And this progression could change for you. It could be different. But really, we've kind of got this idea of foundations to utilities to applications to creativity, right? That's kind of the progression pathway. But the question here is, does that same thing exist in the world of AI? Has things changed for the developer progression pathway? Well, ask somebody that's really big in the AI world, and they will tell you that things are shifting here. Computers are really good at computation. They're really good at those basic pieces. Humans are great at creativity. These are places we need to focus. And that's actually backed up by educational theory. This is Bloom's taxonomy. At the top there, you'll see creativity. Creativity is kind of the peak of learning. If you want to learn more about this, I did a talk a couple years ago on it. Check that out. But so the key here here is that education and learning and that process is all about kind of progressing down that pathway towards creativity. And so that question of, do we need to actually keep these middle pieces? Do we really need those calculators and to-do apps? Now, some of you may be saying these are really useful tools, and they are, but with the whole advent of AI, and even before that, we had some problems that were existing. So there is little room for creativity in these applications. You can only be so creative with a calculator or a to-do app, and you can try and make it really creative. It's probably not going to work. Then you can probably have your to-do app that you put on your LinkedIn profile. It's probably going to be the same, or GitHub profile. It's going to be the same as everybody else's that's out there. So it's really not doing much to set you apart from others. So we already were in a place where maybe these things weren't the best starter projects. And so the question is, how can we short circuit that hello world through to that creativity while also keeping a little bit of that intact? And I actually think that the answer would be really evident to us, because I think Brian actually misremembered when he was remembering this sort of chick coming out of the egg. I think he actually remembered a snake coming out of an egg. All right, so I've got a little video that I'm going to play now, which is a little bit of a hype video. I think that I'm just going to play it on my speakers here because I don't think that we're hooked up to sound. But we're going to play this just to give you a little bit of an idea. If you've been like, what is this Battlesnake Andrew's talking about? I'm going to give you a little hype to get started. What? Not that way. We're going to try and do some hype. Maybe. We're going to go this way. Ah, there we go. Boom. Boom. So at its core, Battlesnake, let me get back over here. Battlesnake is a multiplayer programming game where you try and survive. Anybody here ever play that Nokia Snake game back in the day? It's that, but for software developers. You build an AI snake that is actually competing against other snakes to try and survive. And you do that like this. So the game board is right here. That's just a visualization engine for what's actually happening, which is the Battlesnake game engine sending a bunch of data to your web server, which is your Battlesnake, that you are then processing and determining which way you want your snake to go based on that data. Is it up, down, left, or right? It's that simple, but also very complicated. Because you have to do that in some specific rules. First rule, avoid walls. If you hit the walls and go out, you're done. Second, avoid others. So you run into somebody else's body, you are done. If you run your own body, you're also done. Just like in reality, don't run into other people. It's a bad idea. But that said, just like in reality, head-to-heads are very different. In head-to-heads, the longer snake is going to win. Smaller snake goes away. And then you got to eat food to stay alive. Every time that you do a move in a round, your health goes down. You need to eat food to have your health go back up. And you get longer, which makes it harder to survive. So those are the basic rules. Other important things is the game board is 0 indexed. At the bottom is 0, 0. And you have 500 milliseconds to respond, which is going to be really important when we get to the live demo. All right, so here is the Battlesnake API, 4 endpoints. We're only going to focus on 2. The first is the get endpoint, which is just sending back information about your Battlesnake in a JSON object, so what it is, what its head looks like, what its tail looks like. And then we've got the move. So we're receiving some data about the game, and then you are returning your move up, down, left, or right. This is the actual object. I know you can't really see this, but this is all the stuff that's being sent back, information about the game, the board, the different snakes that are on there, where all the food is. All of these things are being sent to your server that you're using to determine what's happening. So in here, the rules are fixed, but what you build with them is limitless. So you may be saying to yourself, Andrew, we're building snakes. And I say, you are wrong. We're actually building skills and knowledge. And certainly that happens through the course of learning new programming languages, learning new cloud hosting services, by learning new DevOps and automation processes, and by learning new machine learning algorithms. In fact, there's been a ton of papers that have been written on this subject over the past number of years that you should go and definitely check out. But you are probably also saying to yourself, Andrew, these seem a lot like computation. And you're right. We are focused on creativity here. Now you also may be saying to yourself, whoa, Andrew, did I just notice that you used Comic Sans in a professional presentation? And I did. And now this is a good segue to the demo, which may or may not work. And if it doesn't, you're not going to remember that the demo didn't work. You're going to remember some random guy talking about snakes added Comic Sans to his professional presentation. And that's a good sign. All right, so when I was thinking about tech to explore, obviously I work for Twilio. We're a SMS, voice, AI, conversational AI company. And so I thought there's a lot of tools that we have that we could test out. We could use our serverless offering functions and sort of deploy a Battlesnake that way. We could use Sync, which is kind of like our Firebase database system to actually store game data. Or we could use messaging and just like share results via SMS. And I said, no, I will have none of that. And instead, I decided to base this around a live stream that happened a few years ago where people created a Battlesnake that was controlled by their face. And so they literally built a Battlesnake that they controlled by moving around on a camera using TensorFlow, and then they were able to kind of make a snake go a certain direction. Now, I will say that we had to, our engineering team actually had to physically slow down the game engine for this to work, and so it wasn't ideal, and so I'm going to do something a little bit different today, but ideally get a voice-controlled snake by the end of the presentation. And using Conversation Relay, which is a kind of a new thing that Twilio has. It's basically a way for you to make a phone call. It automatically converts that speech to text. It can then be fed into your LLM to do a bunch of fun stuff that you want to do, and then feed back the result afterwards. And the fun stuff we're going to do is process the data with an LLM, and then we're going to feed that back to go up, down, left, or right. All right, so we're going to be using a couple different texts today. We're going to be using Twilio Conversation Relay, Tiny HTTP, which is an Express alternative that I really, really like. We're going to be using OpenAI, except we're not, because I went to a great talk where they said, you should use small language models. So I said, why not do it live in front of a bunch of people? And so we're actually going to be using Ollama and Qwen 3 1.7b, which is a small language model from Alibaba. So now is the moment where we all pray to demo gods that we have a happy snake and not a sad snake. It is demo time. And this one is in If You Know, You Know. If anybody's a gamer out there, you'll know exactly why that is there. OK, so we're going to jump into some live coding now, hopefully. I'm going to stop doing this and start doing choose content. We're going to go our entire screen. You're going to see everything. All right, so we're going to get rid of that. I've got a bunch of stuff up here, but the important thing is VS Code. And we're going to close these guys. And don't worry, I'm going to bump up the text here. But I've got a bunch of files here to start us out. So let's close this. And let's make sure ngrok is still running. Awesome. How's that text size for everybody? Good? Bigger? Bigger. Awesome. Better? Beautiful. OK, so this is a tiny HTTP project. Looks very similar to Express. We've got our app that we're instantiating. And this is, as you can imagine, a Hello World project that is returning a Hello World in text on the page if you visit it. You don't need to see this. Y'all have used Express before. That's great. But seeing what it looks like in the Battlesnake world is kind of cool. And so, again, very similar setup. And again, we only had 4 endpoints that we needed to focus on here. Get rid of this. So we needed to have our get endpoint where we're sending a bunch of data back about our Battlesnake. So its name, color, head, tail, all the rest of that fun stuff. We've got our start endpoint, which just needs to return a 200 response to say, I exist. Same with the endpoint, or the end post. And then the other one is our move endpoint, which needs to send back a move. And here we are going to be sending back right as our default. And that's it. That's a functional tiny HTTP snake that's running just based on code. And we might actually have enough time to run this. All right, so I am now going to do something that may or may not work out in my favor. I am going to move over to my hotspot and hope that it will pick up. All right, let's see if we've got anything going on over here. Let's go into my Battlesnakes, refresh this page. Pray for me, y'all. Whoo. Pray, pray, pray. All right, and I'm going to zoom in here a little bit. What? Control. Da, 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 da. All right. The prayers may not be working. All right, we're going to try another one that one of my awesome colleagues had set up. Oh, there we go. Awesome. Huh, there we go. Just took a little while. Let's go. All right, so we have got our snake in here. I'm going to start this server running over here. I've got ngrok going right now, and we're going to start our node 1 snake. Awesome. Oh, not tiny HTTP. We actually want to get 2. All right, we're going to get tiny snake going. Our battle snake is running. We're going to ping here, and our snake has showed up. We've got a yellow snake with a default head. We can easily go in here, change our color to something different. Change this. Oh, let's do another F. See what color that does. Save that and turn off and on again. And we'll go and ping again. And our color should change. And we'll actually change our head to chomp. All right, save that. All right, and our battle snake is running. And let's just quickly cancel and start up ngrok again. Awesome. All right, so ping over here. We should update to our chomp head. Awesome. So we got our chomp head, and I really hate this. What's black? Is it zeros or Fs? 0, 0, 0, 0, 0, 0, 0. There we go. And hopefully he will be easier to see now. Amazing. Ping. Beautiful. Love that the color isn't updating. Fantastic. All right. So we're going to go in, and we're going to create a match with our CYC snake. And if everything's working right, he should go right. So it's loading our game. Here we go, and this beautiful snake that we can 100% all see and is not at all really hurtful to our eyes is going to go right. He went right. So by default, they go up if the server's not working. We can easily change this to go left, and I realize we're spending a lot of time on this, but it's also just to make sure the server's working. So we're going to go in here, update it, close it down again, update, and let's go in here, create a rematch, and our snake should now go left. Amazing. Our snake that we can barely see definitely did the thing that I am saying. Yeah? Yeah. There we go. Okay, so let's jump into what we are actually here to see, which is not our sort of demo snake here. It's actually our voice snake. And so this is what's actually going to be using some of these cool features that we talked about. So at the top, first thing that we've added is TinyWS, which is a WebSockets extension that is built by the same team behind TinyHTTP. So we need to add WebSockets in here. We've got two things, rules and strategy. These are for our LLM. So we're going to be feeding these into our LLM in order to return up, down, left, right. We're giving it the instruction and strategy to always go right. That doesn't say return right. It just says always go right. It didn't know how to interpret that unless we give it the rules, which is you're going to be given a strategy prompt, output only one word in response to that, up, down, left, or right. Amazing. So then we're activating that TinyWS. And then we've got some updates to my head and tail that you will see in a second, so our eyes will hurt less. Start and end are exactly the same. And then our move has changed. Now we're awaiting that LLM move response. So here's what that looks like. Super simple. If you've never used Ollama before, but you've been doing stuff with OpenAI, it's very, very similar. We're just doing a fetch to this Ollama that's running locally on my device. We're going to go through to this Qwen model, send it back the rules and strategy, and it is going to return a response to us based on what we've put in there. Great. Awesome, Andrew. This is basically just doing an LLM thing. You said that there was going to be voice stuff in here. Well, we've got here this idea of strategy. And strategy is going to be set when we make a phone call through Twilio. So we've added another endpoint, which is our Twilio endpoint. And here we are actually able to instantiate a conversation relay, which is just basically saying use this WebSocket server for this conversation. And then it goes down to the WebSocket server here. And all the power is really happening here in the prompt. So when it gets a message, it's going to pull out that voice prompt, which is us talking to it. It's going to set that strategy to whatever our voice has said, and then it's going to speak that back to us, if it works, which it might, or it might not. And then it's going to be real embarrassing for me. So let's see if we can actually make this happen. So let's go in here. Let's open up our terminal again. Let us turn on node 3. Whoa. Node 3. Beautiful. Let's turn on voice snake. And we're going to create a rematch. And this is, if we go over here, you can see our LLM response is going right. And that should be following our instructions of always go right. Amazing. So it's doing what we want it to do. Ha! Love that. Love that you didn't do what I wanted you to do. All right. Always go right. There we go. You're going right now. Our color hasn't updated, though, because we need to update our battle snake over here. Let me just ping. There we go. Still that yellow color. Man, this is really hating me today. All right, so create a new game. I'm going to create a small board one and start this game. Beautiful, so it should still be going up and right. There's a little bit of a delay there, but you see the actual LLM response is always doing the same thing. Now, I'm going to change it to something different. I'm actually going to give it a call. I'm going to call this number that I have set up, and I'm going to say something different, like maybe always go the opposite of left, and see if it can interpret what that's going to do. And we're going to do that using the Twilio dev phone, which, again, fingers crossed is going to work. I'm going to turn up my volume as loud as it can go, so just be very quiet so you can hear. And let's see if it is going to pick up what is being put down. So, always go the opposite of right.
Always go the opposite of right.
Now, we can't say anything else to it because it will literally return everything back and think that is a strategy. So it should be going left now based on that instruction. Let's create a rematch on this board. There we go. So there's a little bit of a delay there, but it is actually returning left. And we can say the exact same thing again. So we're going to call back this number again.
You like to customize your battle snake.
Always do the opposite of down.
Always do the opposite of down.
Yes, brother. Okay, and we're going to go into our custom game, create a rematch again, and please go up. Amazing, it went up, which we wanted it to do, and that was actually our LLM response. Okay, so this is cool, but I got 3 minutes. Yeah, go ahead, clap. Yeah. So that was cool and all, but I wanted to go to another level with this, and we've got enough time for me to do it, which I didn't know if we would. So I actually built another snake for you, which I call Full Snake. Full Snake is cool because Full Snake does this, not Node, N-O-D. Full Snake does the same thing that Voice Snake does, but it adds an extra layer of actually doing a play-by-play of the game afterwards based on the data it receives. Now, this is a very dumb model. As ChatGPT explained to me when I said, why is this not working very well, it said you're trying to give university level instructions to a toddler. And I said, awesome, thanks for that, ChatGPT. That was helpful. And then I realized I was talking to one AI about another AI, and it was a whole thing. But we're going to start this up. We got our Battlesnake running, and I'm going to give it a call again. I'm going to leave my call going, but I'm going to mute it just so that you can kind of see what's happening here.
You like to customize your battle snake.
Always go left.
Yeah. Always go left.
All right, let's see if it, okay, awesome, it got always go left. Amazing, and now I'm gonna run the game. And there is a timeout here for conversation relay, so hopefully we get it done in time. Awesome, it went left.
Generating color commentary.
And so now it's generating some color commentary.
The CYC snake began the match with a steady march, but as the turns progressed, it faced a series of close calls and fruit pickups that tested its endurance. With each turn, the snake grew longer, its momentum swinging between aggressive pushes and cautious retreats. By the final turn, the CYC snake had outmaneuvered its opponent, securing a decisive victory with a final stretch that left the rival snake in disarray.
Hey, there we go. Amazing. And so the only difference that we actually had there was in our LLM response in Full Snake. Everything else is actually the same. So if we go down here, everything else is the same except for our generate commentary. So in here, all that we've really added is this new board states variable, which in every move now, we are just pushing the move JSON that is coming through into this array, and it's be using that to generate the commentary. And then when our game ends, generate commentary, where we go? Generate commentary. There we go. So when the game ends, it's going to start that, send that message of generating color commentary, and then it is actually going to send the board state, generate that, and then send back the recap. So super, super simple application. It's literally a single WebSocket server that's kind of doing all of the back and forth with the LLM here. And this is all running, by the way, on like a MacBook Air with like 16 gigabytes of RAM, and it's still able to do this. Now, you'll also notice in the last like 50 seconds that I have that this LLM made up a whole bunch of stuff. There was like not other opponents in that game. It was not, almost none of that is real. But it sounded really cool, right? Yeah, let's go. So if you liked that and you want to check it out yourself, there we go. You can grab this if it loads. There we go. You can grab this repo over here. You can clone this repo. I'm going to get out of the way. Clone this repo. I'm going to get out of the way this way. And grab that and try it out for yourself. And then if you want to get in touch with me, that's where you can find me. All of this stuff is linked in the slide deck, that bit.ly link at the very bottom, bit.ly/hellobattlesnake. So be sure to check that out. And that is time.
now. Is it better?
A little bit louder.
Louder?
Yes.
Okay. Cool. Hi everyone, I'm Swizz, and right. Right. So right now I work for a biotech startup where we build some cool stuff for people who program with DNA. But today I want to talk to you about web rendering shenanigans, and we're going to use rewrites as the excuse to talk about it. So what does everyone do when they first walk into a new code base? It's shit, right? It sucks. It's not even using full stack JavaScript. There's a bunch of jQuery everywhere. There's no API. Everything triggers a slow reload, all of that stuff. Like literally every new engineer that comes into your code probably says, this is crap, let's rewrite it, we gotta go from scratch. Now here's the secret of the dirty little secret of the software engineering industry is that everyone is always rewriting. When your company is growing quickly or changing quickly, you know, things change. You can't predict the future. You can't really, you don't really know what you're going to need in 6 months, in 3 months. The stuff that worked yesterday is not going to work tomorrow. And production software is just trash. That's how it is. Reality is hard, and every tutorial you ever read was more or less lying to you. It's not that easy. So the really good companies aren't the ones who build rock-solid systems that last forever. They're the companies that learn how to change the fastest. I actually stole this from a Will Larson book, if anyone knows who that is. He says that when he was at Stripe, he learned that you're always mid-rewrite, you're always mid-change from the old system to the new system, so the better you get at those transitions, the easier your life is going to be and the faster you can adapt to the industry or whatever. Stuff changes. So today, we're going to talk a little bit about how you would actually do that. Your code, how your code looks doesn't actually matter, but your architecture and your code structure really does. And you know, we're not writing poetry. We're writing a 12-book epic saga, unlike George Martin, who is running around not finishing his thing. So we're, what was I going to say? Yeah, so the real problem with Jinja or jQuery spaghetti or Ruby on Rails spaghetti or like monster pages that try to do everything is that they're not structured, and it makes it really hard to adapt. So the component model won for a reason. We want components because it gives us isolated bits of code that are easy to swap in and out and replace. So the first way you can rewrite stuff is using React Islands. So here is an example of 2 tiny React apps running side by side. I literally coded this morning because it turns out StackBlitz doesn't work on an iPad. So it's really hard to do on a plane. So this is 2 tiny React apps. Each of these squares is a full React app. It renders from scratch. It has its own React query. It brings its own styling. And I'm using a very slow random number generator with a timeout to mimic an API query. So when you click regenerate, so when the islands first load on the page, it makes an API request, shows some data. It gets props from when it's being called as a function, renders that. So that's how you can see that these are 2 different apps. And the rest of the page is just plain old static HTML. So if you're paying attention, you'll notice that whichever regenerate I click, it updates both islands to the same number. That's because even though they're separate React apps, they're actually sharing the same React query instance or the same React query client instance, which means they can share memory. They have access to the same bit of memory in your JavaScript, and they can communicate that way. I haven't tested it, but this should work with any global state management thing that you use. So it should work with Xstate. It should work with Redux. Anything that has an external store that it connects to. So, yeah. So more or less, this is pretty standard SPA stuff. We have some HTML. You know, if you've ever looked at Create React App or any of those, usually they give you a div with an empty page, and then you take over the whole page and you build everything with JavaScript. In this case, we have a bunch of existing HTML that we can keep using. So we have, did I make, you can't really see that very well. But at the bottom of that is essentially we have a example island function call that takes a DOM element and some props, and then it renders into the page. And I can actually show you, let's see, let's try showing you a bit more code than that. Oops, that's from the future. Let's see. So I can't run this on my iPad, but I can show you the code. So let's see if I zoom in. Can you see that? You cannot even see that. Never mind then. That's going to make demos much harder. What do I have to press? Well. Okay, I should have done more tech check. How do you tell an iPad to share the whole screen? You don't. Add another one. Oh, move to display. Cool. Okay, so I can do that. iOS, magic. But now I can't see what I'm doing. Okay, so I'm going to turn around. So basically, you have a so example island is a function, takes an element, takes some props, and then it creates a new root, a new React root if it doesn't exist, renders an island wrapper, and then an example. The example component is pretty much standard React. It has it uses a query, it renders some stuff using, I'm using a MUI-based framework that uses Emotion, CSS, and JS stuff. Nothing super interesting there. But it can render static props that come from the server. Now, this is a way that you can communicate from your old code to your React islands. And then it has the standard thing to run a React query. So that is all fun and good. Now, what happens if I click this? Okay. So basically, you can build these highly interactive components and move them around. And because you have a shared query client, all of the islands on your page have a shared memory. So even if they run the same API requests, or if the API requests are invalidating, everything works the same as if it was an SPA. The other nice thing is that you can keep using your old or whatever existing routing infrastructure you had. It's essentially a multi-page app. I think we used to just call them a regular web page. Now it's a multi-page app, but it's basically if you click a link, it's going to reload, and you're going to get more islands, or you can navigate within the island. Cool. So that gives you the ability to build modern JavaScript-based islands of high interactivity. Now, and you can do form submits, because I think a lot of engineers forget this. But if you wrap a React component in a regular form and then render input elements, you can submit to your same old form endpoints. Just do a submit event. And this actually works. We use this in production. You wrap a React island in a form, and it works. So this gives you the ability to have highly interactive islands inside your normal HTML app. But what about the other way? What about all the code that you already have working in HTML, in old HTML and jQuery? How can you get that into React? My idea for this was to essentially abuse React server components, and that's what this talk was originally going to be about. I couldn't get this to work. So the idea of React server components is very similar to if you've ever used Hotwire in Ruby on Rails, or Next.js is also based a lot on this stuff. But it's basically you have a React component on the left. You click a button, it makes an API request, and that API request returns a React component, and then React replaces part of your component tree with that new component. Dan Abramov calls this React for two computers, and it's essentially a way to swap, to render things on the server and then swap them into your UI. I couldn't get this to work because we don't have a JavaScript backend, so we use Python, so in the Python world, React is not very well supported. However, oh, and yeah, this one of the big comments people make on this is, wait, doesn't that couple your front end and your back end? Yes, it does. And long term, if you've ever worked in industry for a few years, you've probably noticed that the client and server never stay decoupled for very long. If you're writing full stack apps and you're doing server code, unless you have more than one client at the time of writing your API, you are almost guaranteed to write an API specific for what you're doing on the client that day. So React server components and and a lot of the modern front-end tooling is like, fuck it, let's just say they're coupled and build and like, you know, let's not kid ourselves that we're not coupling these things. So I couldn't figure out how to do the thing with React server components, but luckily in the Python world or in the hypermedia world, you have HTMX. So here is, yeah, exactly. HTMX is actually really cool. There was somebody was joking on, I think on Hacker News, that the X in HTMX stands for JSX, and the inventor of HTMX was just like, yes, that is the same thing. HTMX and React server components and Hotwire and probably some others, they're all the same thing. So here's an ugly UI that I built with HTMX. It's basically a little admin tool to manage inviting users to a lab. Doesn't matter what that means, but what matters is that I could do this, make it more interactive than it was before. There's no full page reload. When I add a person, it just shows up on the page. When I click delete, it asks for a confirmation and it goes away. No page reloads. Everything's happening in JavaScript. But I didn't actually have to write almost any JavaScript. I just did this. So what is this? This is this is basically the same code that we had before. I didn't need to change the backend almost at all. And it's doing a very SPA thing. You have a div that loads, that triggers on load. And so you have a div that gets its contents from a GET API using URL4. It renders itself by replacing the inner HTML of a div. This is very similar to injecting a React island. And the loading triggers when, the GET request triggers when you load the page or when you trigger a user's updated event from the body. And then the form below it that actually does the work is just form with the method post, and then instead of action, you write xhpost, which is like an HTMX syntax thingy, and now this form can submit to a post to a server. The server responds with in this case, it responds with the HTML for the success message, and a header to trigger the user's updated event, and then the browser makes a request to the server, re-renders the whole list of users, and shows it again. Very little JavaScript, basically no rewriting on the server, the same old stuff that renders HTML and some jQuery works as before. And then another nice thing about HTMX is that you can do these xhpost and etc. Requests on any element. So here we have the the delete button, where if you look over here, I'm just adding when you click on this button, issue a delete request to the server, let the server do whatever, and then ask for a confirmation before you do that. So that's nice. We can now build somewhat interactive UIs without rewriting all of our server stuff and all of our server-side rendering that was built in ancient technologies from like almost 5 years ago. So, you know, this is cool. It means that you can move quickly, build these semi-interactive things, but you don't have to rewrite everything. So, the ultimate dream that I have is, what if you could write the same components as you do? So, what if you could write a component and it then behaves correctly, whether it's rendering on the server, rendering in the browser, maybe rendering as an image, and your product engineers don't have to think about what they're actually doing. they're just writing React components, the same as any tutorial tells them, the same as they learn in a boot camp, the same as they learn in documentation, or even whatever an LLM would spit out when they're using Cursor. But then the framework figures out what to do with that. So we're gonna, so the way I got that working is TanStack Start. Tanner did all of the hard work for me. I've just been playing around with it. And it's actually cool timing because they just released a V1 candidate, on Tuesday. So I've been playing around with it since like March or something. It's really good. You should go try it out. I'm excited to play with V1. But today I wanted to show you a couple of demos of what we built with TanStack Start and React Islands. So let's see, what do I need to do to make this work? So I switch to Safari, and then Safari is over there, and then I go to, not this one, this demo. All right, so this, nope. Move to display. Okay, now you can see it. So this demo is where's my mouse? Okay, so this demo is, this is something we've built at Plasmidsaurus. This is a DNA visualization for biotech researchers. I don't fully understand how it works, but the kebabs on a string represent features in DNA of some engineered organisms, and researchers look at this and they know what it means, and they're like, oh, cool. It's essentially like looking at a diff of your code on Git, and a normal person looks at it and is like, this is meaningless. But when you look at it, you say, oh yeah, this function does a thing, that function does another thing. This is similar. All of these shapes mean something to biotech. So if I reload this page, you see the HTML loaded first. Most of the header is in HTML. Everything else is in SPA. And then we download on the client. You'll see there's a loading state. That's downloading DNA from S3, and then it's visualizing the DNA in the browser using SVG. And now, I know this isn't impressive if you haven't done it before, but it's actually pretty interesting because each of these visualizations represents a couple 100,000 data points, and JavaScript is parsing it all, figuring out what it means, and then displaying it. And then if you mouse over it, you get some nice, what is this? You get feature names, which I'm told are super meaningful. And then if you scroll down, you can see more detailed, if you remember from, so you can zoom, the bottom is an entire DNA sequence of a simple organism. And then you can see so here you can see that this researcher, they tried to build the bottom DNA, but they got the top DNA and they're slightly different, so this diff is showing them that there's a problem. And then we have some highlights, and you can mouse over this and it tells you what's going on. So that's all pretty fun. Now, this all happened in the browser. Now let's see, how do I change to a different tab? Now you can just move that same component into TanStack Start. So here I have TanStack Start running on a Lambda, and when I reload this page, you'll notice that the initial load is all there. There's no loading state in the browser. It's just it's actually returning plain old HTML. I don't know how to do it in Safari, but if I turned off my JavaScript, this would still load and I would still see what's going on. And then once it's loaded, it hydrates, which means it becomes interactive. React runs over it and does its thing. And then I can mouse over and everything works the same as before. I can go down here, I can click on these things, and basically I can see the same differences in DNA. Now, and another cool thing I can do is I can then go and I can say format PNG, and let's say we want an image that is 1024 pixels wide and let's say 600 pixels tall. Let's see if this works. Oh, I made a typo there. So what I'm expecting here is to get these same components, the same UI, but as an image in one request. So I'm not just in one request response cycle, I should get back a PNG, and I did. So this looks the same as before, but I can actually go save to photos, and I don't know where that showed up. But it's an image, it downloaded as an image, and the way this works is that it server-side rendered the whole UI using the same components, and then started up a Puppeteer, took a screenshot of it, and returned that as the response of my server-side rendering. So instead of returning HTML, it just returned a straight-up PNG. We're getting short on time. So the way that, okay, we can skip this. This is a GIF showing you kind of what's going on. But the magic that made this possible is that with TanStack Start, you can have a shared query cache between the client and the server. So on the server, so when you hit the Lambda runs a Node.js server, renders all of the React in memory. Actually, it runs a Node.js server. The server then makes an API request to our Python server to fetch the data, fetch the DNA data, analyze it. So fetch the DNA data, returns it, then renders it using React, returns the HTML, and then returns the HTML and returns some pre-populated query caches. So then when the same component runs on the server, on the client, that component already has the query cache populated, and it's like, cool, I don't need to load this again, so you don't get the loading spinners. The basic code for how this works is I have a server function. This function, no matter where I call it from in my JavaScript code, will always run on the inside the Node.js server, which means I can safely use process env vars, so I can safely use API tokens. I'm not going to leak any secrets to the client, and it's making these requests these will never leak to the client. And then in a route, this is where you define the actual URL where all of this happens. You have a component which I'm not showing here, and then the route loader basically says when you come to this URL, whether you're a server or you're a client, fetch the data, and then in this case I'm populating it into the query client, which then gets propagated to the browser where it doesn't need to make another API request. So this is where I feel like whenever I try to explain this, I look like that crazy guy from Always Sunny in Philadelphia with my whiteboard. But it's really cool. Coupling the loader to your router makes it really easy to coordinate queries, and then you can write a bunch of actual UI components without worrying about how loading works and whether they're on the server or not. So hopefully this convinced you to give TanStack Start a try. We had an excuse to talk about some rewrite shenanigans and some how modern web rendering works. You can use this QR code to sign up to my newsletter, download slides, all of that good stuff, and you can find me on the internet as Swizets. Thank you.
agents onto that list. Now, AI agents, let's move on, are taking the world by storm. So this is a chart of how many API calls are being made per day, broken down by month this year. So we get to about the middle of the graph, and that's the end of this month, and then everything beyond that is a projection. But everything prior is what's happening now. So the blue line is us. That's the developers. That's the automations. And our usage of APIs has been climbing little by little every day. Now, if we backtracked many, many years, it would look like that, just slightly down. We haven't really changed that much in how much we've used APIs or made API calls every day. But if you look at that orange line, that is a much steeper slope. It almost looks exponential, kind of. Maybe if we zoomed out, it would look exponential. But the point is about in May of this year, the AI agents are winning. They end up making more calls per day than we do. And that trend over time is only going to continue to go up and up and up. And that separation between these two lines is only going to get further and further, which means, if you think about it, humans are still going to use the APIs that we're building, but to a much smaller degree of what AI agents are going to be doing. Now, the usage has changed, the market share has changed, but also so has behavior. Expectations of how the APIs that we're building and consuming are different. A lot of times we'll see people that want to just say, why can't I just figure out what I want? I can ask Alexa something and it can tell me what I want, or I can ask ChatGPT to do something and it tells me what I want. Why can't all APIs just do that? Well, that's not how we've designed them in the past. That's why we're here right now. So if we're talking about, should I eat that red egg? Let's keep coming to that, because that's an important question as far as this presentation is concerned and in life as well. The process we're used to, developers. Let's say we're trying to figure out, should I eat this red egg? We're going to go to the website, the docs site, for this API that we're integrating with. We're going to read through. Docs are nice. They have a nice story. They have business use cases along with the ins and outs. We're going to pick the endpoints needed. Usually it's not just one. Usually it's a whole bunch of different endpoints. We're going to build the logic. We're going to chain them all together. We're going to take the output from this one and use it as the input for this one. And then we're going to go eventually and get our answer. Easy enough. In the experience, as we've all seen, yay, we have really nice story-driven documentation. We have business use cases directly in there. And if we're really lucky, we get good quality API documentation. And this is a rendering of an open API spec. If you guys have ever used that, highly recommend Swagger. It makes these really, really nice and robust documentation. And it lists everything. So let's do this. Let's figure out, should I eat this red egg with these endpoints? Well, if we're trying to figure it out, first one we're going to do is we're going to list our eggs. Honestly, I wish I had like any other room besides this one where the TV was way bigger. Take my word for it, that one is the list eggs endpoint. We're going to find our egg, we're going to load it by ID, we're getting all the information that we can about it. But unfortunately, that endpoint doesn't have everything that we need. So we're going to call the storage endpoints. We're going to figure out how is this egg stored. We're going to see all of its lifelines. You know, it was stored here, 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 and here. And we're going to load each one of those to get information about the storage of that egg, about its entire life. But that's not enough either. Now we're going to go in and we're going to see, well, has this egg always been red? Maybe the inspections that we had after it was laid, it was white. So we're going to list all the inspections, and then we're going to iterate over each one and figure out, you know, what happened to this freaking egg. And we have it right now, so we might as well, while we're here, add a new inspection. It's red now, so you know, let's leave it better for the next guy. But because we do our due diligence, we're also going to figure out, are the other eggs in this batch also red? You know, another key indicator. Do we need to do something with the rest of the eggs? So we'll list those, get that batch, and then we'll put in a note that this one is red. That's how we work. That's how humans work. Agents don't. that is not what they have access to. AI agents can't go to doc websites and read story and figure out the business context. They don't get to go in and read the open API specs. What they have access to are tools. And they have to rely on themselves to build out these workflow via chain of thought. So they get this big list of tools, and then they say, okay, well, I probably need to do these 10 things. I built this in here because I didn't know what everybody's experience was with AI, but from all the talks I've been to, you guys probably know what a tool is. But it is code that AI agents are running. Made popular by MCP. And in many cases, these days, the trend I've been seeing when I put my ear to the ground and I hear what people are building, a lot of times our APIs are being taken, wrapped, and given to LLMs by not us. It's integrators that are doing it. It's solo devs that are doing something. It's whoever else. The point is, not me. And because of that, there's some work that we have to do in API design to account for it. With the big thing being toolability. Now, that is a word. And what it means is it means really defining your API endpoints strongly. You need to do some very critical things that makes it really easy for somebody to come in with their open API to MCP generator. So it makes your API endpoints pickable, meaning the LLM knows which one it needs to call without a shadow of a doubt. They are fillable. I'll get to this in a second. And they're understandable. Really, the key here is remove all ambiguity, because we know what happens when LLMs are presented in ambiguous situations. They make stuff up. We don't want that. So let's look wrong way. Let's look at what an API spec or an endpoint definition would look like before, basically the docs we generate now, and after, which are ones that are really, really good for LLMs, for somebody to come in and basically steal your endpoints and use them on your behalf. We can see that okay, right? Yeah. So this one is the one that was written by the developer who was told by their boss, you have to write API docs. So they did, because they had to. And we get things like, okay, color, refrigerated, date, and float result. And that's it. And basically the bare minimum. These are the things that come in. Good luck. That's not going to fly with LLMs, especially when your data is being taken and used in a way that you may or may not have intended it to. So what we do is we have to make it pickable. Now, man, I can just keep going the wrong way. What does that mean? Now, when these generators run, they take your open API specs and they say, here's a tool. What they're looking for first is, what do I call it? I don't want to call it /eggs, egg ID inspections. I want to call it something meaningful that removes ambiguity. So we use operation IDs. Very easy, and that's the tool name. That's one of the things that is supported in the Open API spec. If you're not already doing it, super low lift. Just describe what you're doing in real time, in natural language. Create egg inspection. What we also could do is make it fillable. I put a pin in this. We're taking that pin out. We're going to talk about it. We have to strongly define all of our properties in any way that we can. And what does that mean? Well, looking at the left side, we have color as a string, and we have, let's see, it doesn't look like anything's required, and date is also a string. But we can do better than that, all using API or Open API specification that exists today. So things like, well, let's say you can't add anything else to this endpoint, just something that LLMs like to do. It thinks, I know better than you, I'm going to add more metadata. So it does. If we say additional properties false, that means, okay, no, I can't do that. We also have enums. What are the valid colors of an egg? We have white, brown, red, blue, green. We have formats as well. You can also use regular expressions to say, if you have a string, it has to match a specific pattern. Really just narrow it down as tightly as it can, so when the LLM is reading this, it will read this. It knows what to send over to your API. And the last thing here, which is the understandable piece, is let's remove ambiguity in the property names. Let's remove ambiguity by providing examples. All of these things are going to be presented to the model when you give it your tool definitions. So keep doing that. So in our example here, we've changed color to shell color. Could have been the bird color before, I don't know. We changed date to laid at, because date could have been the inspection date, but no, we meant what date was the egg laid at. And then we have an actual meaningful example that has all the fields filled out. So we can go in and see, okay, well, what have I done before? So that's one. That's one. We're going to cover 3 big things today. 2, we have to assume a change in behavior, where the majority of our inputs to our API are going to be coming from LLMs. And the majority of the reads are going to be coming from us. Now, why do we say that? Well, who here, show of hands, another interactivity point, who likes filling out really long forms? Yeah, okay, I'm glad you didn't raise your hand on this one. So I don't, nobody does, but you know who does? AI models do, because they were trained on the internet and on everything. And so if you add a bunch of fields to your API, that LLM is going to add those fields to that API. And you know what that's going to result in? Really rich data. Really rich data. And guess who benefits when you have really rich data? We do, which is super great. So just from this little swap in mentality where I'm going to assume AI is doing all the ingress and me as a human and my other human peers are doing the egress, we really can optimize our API design for that pattern. How? Well, for writes, let's talk about this. So who's doing the writes? The agents are doing the writes. We can load up our API endpoints now with optional fields. Optional, not required, because we can't throw humans to the wind in case we're still doing some of the data entry. So we're going to have as many properties as we can think of and make them optional. LLMs are always going to fill those out. Yeah, so right there was the optional piece, only making the tag required for humans. Validate everything. So again, what do LLMs do when they don't know the answer? They make stuff up. So when it comes to the actual implementation piece, your code backing these endpoints, you need to make sure that you're actually doing proper data validation. Things like, are these dates in the future? Are the chicken breeds that are being passed in here, are they real? Don't just trust that the data coming in is legit. Now that's not new, you should always be doing that, and we should have been doing that for all of our careers, but it's extra important now. The last thing here, and this is kind of a novel concept unless you do strict REST, is build in chain of commands, the now what. So let's say we add a chicken into our system. What do we do now? Well, we can add things in our responses that say, well, usually when we add chickens into the system, the next thing you're going to want to do is schedule it for an inspection. And so you give it the operation ID, which is the tool name for that LLM. It'll pick up on that and it'll say, oh yeah, okay, I can probably do that next. And also, on the error side, when things do go wrong, include that step in there to say, hey, you messed up the data, you need to fix that. Or in other scenarios, you need to go fix this other entity before you can update this one. So making sure you tell it in the response what you can do next, what are your options. That way you can kind of coax the LLM to doing what you want. Reads. I'm going to start picking up the pace here because still got a lot left and we have 8 minutes left. Reads, so us. How do we adapt for us? Well, we're going to assume that we now have extremely rich data in our system, that the LLM is generously donating to us. So what we have to do is to kind of taper things back. I don't always want 100 fields for a specific entity. So what we can do is we can build in named views into our gets. So we have things like a profile view. Give me everything. Or in most cases, I want a summary view. What are the most important fields on this entity specifically that I can use for the majority of my use cases, that I don't need to load everything. Then, of course, you can do things like a compact view, where you say, just give me the things that I need to put this thing in a list. Or just give me the bare minimum that I can do something and interact with it later. So how do we do that? Because I'm not going to build 3 endpoints for a get for every single get in my API. Well, what you can do is you can actually build that into a query string parameter, an optional one, where you can decide if that query string parameter is not there, what's the default view that I'm going to provide. Often it's going to be the summary. Then you can optionally call the give me everything or just give me some. Okay, 6 minutes. Do more. It sounds like a joke. It's not a joke. Now, what does do more mean? This is a guinea fowl, by the way. Fun bird. So let's look at a workflow. The workflow we talked about at the very beginning. Should I eat this red egg? Right? We have our list eggs, and then we're going to go and get the egg by ID. Then we're going to do the storage records, the inspections, the batches, and then we'll arrive at our answer, yes or no. Should we eat this egg? Probably no. As humans, it's really easy to build. I mean, easy subjective. But we do know how to do this. This is a solved problem in many, many different frameworks and use cases. So that's great. Humans, no problem. We don't actually need to do more when we're just banking on humans using our API. However, here's the pause. AI agents, they're unpredictable. Unpredictable. I said this the other day. Well, we want our AI agents to act like firstborn children, where you tell them to do something, and they do that thing, and they do it really well. But as of today, AI agents typically act like second-born children, where they don't do that. They don't do that. And why is that? Well, that's because there's a lot of planning variance, so they're not deterministic, right? So you ask an LLM to do something. If you ask it 10 times, it's going to give you 10 different answers. Not exactly the same, also not exactly different, but when we're talking about large workflows, you got to accommodate for that. So if something goes wrong, so let's say it does this plan, let's say it nails, these are the 10 tools I need to call in this workflow, and it goes through and something fails, well, it's going to say, shoot, that failed, I didn't expect that, let me replan. Let me figure out what I need to do now. And it might take a detour, and ultimately you're going to get an answer that went maybe the wrong way and doesn't have all the exactly right things. Last thing here for agents is you run into context pressure, and that really just means if this keeps iterating over and over, it's going to keep building up this context window. It's going to get bigger and bigger and bigger and bigger, and you're going to get like prompt dilution, and you're going to have the LLM weaken in performance because it's trying to work with so much data. So let's walk through what an agent would do in this situation. So list eggs, good. Let's keep going. List storage records, good. List inspections, oh shoot, that failed. Let me replan. Let's figure out what to do. Okay, we should do list batches now instead. Skip list inspections, that never ended up working. Now it's gone to the batches. And it thinks, okay, well, you know what? Maybe there was something wrong with the shipment that came in. So now it's gone completely off course. It's learned about the shipments, and now it's like, what was I doing again? Red egg? And then it gives you this tangentially related answer that isn't really what you were looking for. The answer to that is build workflow endpoints. Do more. So maybe instead of relying on these 10 endpoints that we had before, we have one. Assess egg edibility. Now you, the developer, the owner of these endpoints, this API, get to control what happens. So this one can be an entire workflow where it loads the egg and then it fans out and does all these things. And then it's like, okay, well, we need to go update while we're in here. And we're going to consolidate everything. We're going to turn the results. No, don't eat that red egg. That is a bad idea. So not only do you control what the workflow is, it's deterministic at this point, meaning you can run it 100 times. You're going to get the same result 100 times. You also get the opportunity to increase performance by fanning out operations, so on and so forth. So practical build tips for workflows. You, as the owner of the API, need to pay attention. You need to look at your logs, look at your metrics, who's using what in what order. You need to really hone in on the business use cases that people are using in your API. And once you figure that out, then you can determine, is it worth me building these extra workflow endpoints for the users? Now remember, people are going to steal this, and they're going to turn that into tools. So you need to be very explicit when you're documenting what this does. These are all the actions that it does. These are the rights that it's going to do when you actually go and make a call. And this is what you should expect on the other side. And then lastly, this is a whole conversation in itself. When you're doing workflows, you always need to design for idempotency and compensating transactions, because agent's going to fail. They're going to try again. They're going to get retry storms. So you don't want a bunch of data coming in multiple times. And consequently, if something fails and you abort, you don't want a bunch of orphan data. So you have to have ways to back out of the things that were created. OK, yes, 1 minute left. So recap. Here we go. People will steal your API endpoints and turn them into AI tools for themselves. And that's important because that means we have to be very explicit in how we define the documentation of how to use the endpoints, which is everything we just talked about. Let's create those operation IDs. Let's create those very meaningful property names. Let's include the enums and anything else that we can to remove ambiguity. There is going to be a data overload. If we go and we design these endpoints to accept a bunch of data, a bunch of new optional parameters, you have to be prepared for that. You can't just keep serving 100 different fields every time something gets called. So that's something where you could do, implement caching in there, but definitely something like, let's pare down those views. Something like GraphQL is actually really useful for that. And then lastly, and probably ultimately the most important one for long-term success with business outcomes, is pay attention to what people are doing. Figure out what these big multi-step workflows are that everybody's doing, and build it yourself, and then to have that turn into a tool. That way these agents can reliably do it. Okay, nailed it, 5 seconds left. Thank you, everybody. Remember, do not eat the red eggs.
All right. Thank you everyone for coming in, spending the waning hours of a long day with me. How have you liked the conference so far? Good. It's great value, right? Yeah. All right. So I'm going to talk about a topic called high velocity engineering. You might have heard of prompt engineering. You might have heard of context engineering. This one goes a little bit beyond that because it's specifically about building a system for using AI within your entire SDLC. So everyone knows about vibe coding or stuff like that. But we're going to take this to the next level where we apply engineering principles to AI coding. So to tell you about me, it's funny number. Yeah, this year I hit 30 years as a professional software developer. Many years beyond that, I always joke with people that, if Agent K saw me on the street, I was walking around with a little DOS manual. That's back when they used to print manuals for software. At 8 years old, going to Sears and hacking into their computer, finding the games they installed at 8. It's kind of funny, and all the way up to here. I spent 6 years at Microsoft in their commercial software engineering team, where I was working with some of their biggest clients, bringing them to the cloud, and over the last 2 years working with AI to integrate as well as exploring engineering practices with AI. My main focus was on cloud engineering, edge computing, so IoT, bringing data from disparate locations into the cloud. And I love domain-driven design. I fell in love at first sight. And pertinent to today's talk, I've focused on AI again. So what is high-velocity engineering? It's about reducing rework and maximizing your flow. When you prompt the AI and it goes off the rails and says, oh, yeah, I know what you mean. That was my first experience with vibe coding. I said, oh, you know what? I want to learn this, so I'm going to apply it to something that I understand or that I want to do, a pet project. And at the time, I was like, okay, let me catalog my magic cards. And I said, okay, well, give me a list of secret layers, let me add it to it, and while you're at it, add in the price for it, how much can I get if I decide to sell it? Yeah, that didn't work out that well. It's like, it guessed what the secret layer was for me and knew of the secret layer, but it said, oh, there's these 1,000 cards with secret layer identities. Who knows magic? I'm sorry. A few of you. Okay. It's a 30-year-old game where basically all the cards are still in play. The older cards are very expensive. The newer cards are less so, unless you're playing with the Final Fantasy deck. But basically, I was telling it a very large scope task to do. And that's where I found out, oh, that's not how you do it. So I threw it out. That was my first lesson, is treat this as a sketch. Treat it as disposable. Don't fall in love with the code that the AI generates. It's disposable. It's free. It's like saying, oh, if I hit F5 on my compiler, I can't throw that away because it took so much time for me to build it. No. You rebuild it. You change the code and rebuild it. You change your prompt and rebuild it. When we talk about generational languages, you have assembly as the first generational, then C as the second, and they go up from there. I look at AI prompting as a 6th GL. We're speaking natural language and we're getting working code from it. But you have to understand how to properly engineer those prompts in order to get what you want. So we need to treat it as part of our engineering system and take a mindset shift that maybe look at your AI agent as a junior developer. What does a junior developer have that's beneficial? They're eager, right? They're ready to go. They can pump out a lot of code. What they don't necessarily always have is context. You know, they don't know the whys or the higher level skills that helps them take a really large scope item and break it down. You're not going to tell them, oh, go out and build a clone of Twitter. You know, you might get the simple parts, but you won't have like high availability or duplication or other such things because they don't know that yet. Just like, as of now, AI agents don't know. You can't say, build a Twitter clone that actually scales to agent. So you have to give them the prompts, the context, and the guidelines to help them do so. As I said already, context. Coding standards, you know, that's part of what you need to provide it. Like, how do I name a variable? You know, what does the shape of a class or what patterns should I use in developing this? Give them examples and templates. You know, if you have coding standards or an existing vertical slice, you know, sometimes during onboarding, good companies, good teams train their developers on, hey, here's how we do things. Go out and make a dummy example that works as we work. And that's what, excuse me, throw this dry. That's what you want to do for your AI junior developers. So your co-pilot first year out of college. And then of course, guardrails. You want to verify that their code actually works, that doesn't break existing code, and feedback loops. So you want to give them a review on the work they've done so that they can learn from it. And the same thing happens with Copilot. You need to give them onboarding docs. So this onboarding would be in the form of an instruction file. You give them coding guidelines. You give them examples from your existing code base, or because Copilot can also examine your code base so they have the full context and can understand it almost right away. And of course, feedback. So you're going to iterate on your prompts so that they can become better and get better results. And of course, the guardrails are still the same. You give your automated tests, your static analysis, and you know, that's where engineering comes in. You're designing a system to support your AI agent rather than just hope this works. So here's a simple example. You know, a junior developer might ask, do we use snake case or camel case? The correct answer is Pascal, of course, but you know, thank you, sir. Mark, the man of the minute, of the hour, of the day, hero, our all hero. So yeah. If you don't tell Copilot, you know, your coding output might be all over the place. And, you know, because at its core, your AI agent, your LLM, is a text generation engine. Now, it might have some things baked in that make it a little better at writing code. But if it saw an example where, you know, one algorithm was coded in a certain way and another one was coded with a different style, you're going to get a mixture of styles, unless you tell it. And so you can do that with your prompt instructions. And I'm going to give a few examples at the end. So yeah, so definitely, if that matters to you, which it should, give it to it. You know, have a coding standard document that it should follow in its context, and so that you don't have to write it over every time. Domain context is big. You know, if you're trying to build an app for buying fried chicken at your restaurant, and Copilot assumes that you're trying to build a chicken coop, it's going to have the wrong context. They won't mesh. So give it information about what you're building, not just assuming that, you know, because I say, oh, here's a customer, you know, it's like, okay, maybe they're buying eggs. No, we don't sell eggs. So again, like, you know, your junior developer might ask, what does the customer mean? And you know that knowledge. You know the knowledge. You need to provide it not just to your junior developer, but also to your AI intern. So prompt engineering is important. You know, think of your instructions as code assets, because they are. They'll change over time. And you know, as you get more familiar and investigate and explore more about what's possible with AI, you'll get better at prompting. And those prompts should improve and get closer and closer to what you need. When you see it go off the rails, think about how I could have made a better prompt, or how I could improve my prompt to make it do more like I want it to do. Refactoring is important. You know, as you review what the results are coming out, look at your prompts and see how you can improve them. Most important is specificity, because your AI, your LLM has a limited context. So think of it as like your memory stick on your computer. Once it overflows that context, you'll start seeing things like, summarizing conversation. So that summary is like a mark of doom, because it might miss important points. The way to keep that from happening is have an agent focus on a very specific thing. Have one agent call into another agent that does the other specific thing, or work on your chats for very intricate purposes. I have a chat that makes a plan for what needs to be done. So I say, hey, I want to build this function or this feature in my application. Make a plan for it. Say how you're going to do it, because if you just say, go ahead and do this, it'll just make up its own plan and start rattling off and like, oh, wait, this doesn't work. I'm going to do this now. It's like, no, I like that. You just need to fix this one line here. But if you don't do that, if you just let it run at it without context, context matters always, it will, you know, it's almost random. So we have a pattern that we call two-phase prompting. And that first phase is make the plan. And then you can cycle back either through prompting or on your own and say, hey, for step one, we need to do X, Y, Z instead of A, B, C. And I'll show examples in a little bit. But definitely separate the context specify the context for the specific task, so that you're not overloading the LLM. You know, there was a YAGNI or YAGNI dry solid single responsibility principle, right? Treat that with your, that's the principle that you take over from coding to your AI engineering. Finally, you know, we're not at the point of if AI becomes more important to the job of a programmer. It's happening. It's already here. The train is rolling out the station. You saw during our keynote where the CTO said, yeah, you know, we're exploring, and it's not just the big tech companies. It's filtering down, especially as people see more productivity boost from it. So how do you advance your career, protect your career? Because just coding isn't enough. You know, like he said, you need to start looking at the bigger business. I talked about this 3 years ago at Render? 3 years ago, where I talked about, yes, Justin's here. You know, he gave me the opening talk, not the keynote, but the opening talk of Render, and you know, I talked about being a product-driven developer, understanding the business that your software is supporting, and this is what you need to do now to become more bullet resistant. We can never say bulletproof. As AI becomes more embedded, our value as engineers shift. The skills that are important go beyond coding, go beyond even understanding the framework deeply, because I will be the first to admit I can prompt an LLM to create the same code or better than I do, with more edge cases, with more engineering capacity than I can in the same amount of time. I can tell you easily that something I can prompt in 2 hours would take me a week to do. So the actual coding isn't going to be as valuable going forward. But learning your domain, being able to talk at a business level of the value of your code, getting at a higher level with system design and architecture, being able to talk about systems and how they interoperate is important, because that's what you're going to be prompting the AI to do. And sorry. Oh no. Like to access, no, I don't want you to access my camera. And then of course prompt engineering is key, because that's what's going to drive your work. And the rest are just people skills, you know, what they call soft skills. Soft skills are going to be more important going forward. So that's the end of the prepared talk. I'm going to show off some code now. And this is actually from, oh my Lord. Oh wait, I can see it over there. Okay, I'm gonna go to mirror instead of extend now. Change to mirror. There we go. Okay. Then we'll fire this guy up, and I know it's tiny. But here is my Copilot instruction once I zoom out my, and so this is from this is from quite a bit of refactoring on this. But basically, you know, it breaks down everything we have multiple instruction files, and then we tell it based on what task you're doing. Look at file A, B, C, or whatever. And so we have, again, when talking about specificity, we talk about epics. How do you break down epics? How you break down stories, feature development, project planning, issue management. So we use AI to create work items. We say, hey, I want to do this story, make a work item for it. And those work items go into such detail. Give up GitHub. Oh, might help if I was connected, huh? Come on, wake up, wake up. There we go. Nope. All right, well, trust me. They're very detailed work items. And so then we also, so I can go through my chat history. So, yeah, like the last time I was working on this, it was very, very high volume on high load on the system, so it failed a lot. But so here it is. I'm saying, since I've already told AI to make this work item for me, I say go ahead and assign it to me, move it to in progress, create a new branch, blah blah blah, and create a plan according to the two-phrase prompt instructions. Those prompt instructions are critical. It's saying, hey, don't just start trying to implement it. Make this plan. And we keep our plans in source control because it helps us track what's been happening, and then like I can pick it back up from a different machine, or another coworker can pick it up. But here this plan is what, 250 lines long, and it goes through as it completes it. It marks it off as done, and before it proceeds, it says, hey, we've got to wait for the review and approval, and then it executes, and it breaks it down. And if we see, hey, this one step needs to be broken further down, we say, hey, let's make a new issue for this step, and then go through the whole process again. And again, this issue 62 was our first vertical feature we created, which used authentication, used Azure OpenAI. It had React Native hitting the Azure function backend, hitting the Cosmos DB, authenticated via Microsoft Interest. So it's a lot of working parts. And this guy did it in 2 hours. That would be a whole sprint normally. It's a simple vertical feature. I'm just creating one goal, but it's the first time we hit the entire vertical slice. And so by doing the upfront work in creating our prompts and giving it context that it can rely on, we were able to hit that in 2 hours. And the next one should be quicker because we won't be dealing with the problems we do. Like, I think there was our local development environment wasn't authenticated to the back end, so we had to do a work hour. But we won't hit that problem because we solved it. So the next one will be probably an hour. But if you want to follow along, we're pre-launching. Hey, there we go. Come on, you just loaded. Okay, we're pre-launching GoGlowUp.com, and what this product is is a productivity coach driven by AI. So sign up to find out more. We're going to catch up with you and get in early. You know, New Year's coming around. Stop making resolutions, or make your final resolution to glow up your goals. And with that, thank you for spending your time with me. I'll cut myself.
Right, good evening everyone. Can you guys hear me okay? Cool. Yeah, I'm Donna. I am a software engineer with Slack, and over the past few years, I've got the chance to work in a couple of 0 to 1 projects, and I'd like to share a few learnings from that here. Just to start with a bit about me, mentioned I'm a software engineer, and past couple of years, I've been doing a lot of full stack and backend development, both 0 to 1 projects and 1 to N projects. And it's been a mix of full stack and backend roles. So a lot of these projects, it wasn't by purpose that I got into it, but once I started working on it, I felt like, yeah, that's something that I'm really enjoying, and there's a lot of learning and growth happening in these projects. So outside of work, I am pretty active in a lot of organizations like Women Checkmakers, AnitaB.org, IEEE, etc. And also, I have a leadership program that I work in parallel, which is Show Your Word Circles. So we have a couple of cohorts done already, waiting for a few more. And that's a bit about me. So here's a few topics that we'll be discussing today. What is 0 to 1 as such, and what are some of the phases through which we will go in? How do you identify 0 to 1 projects? And some practical tips, what are the impacts, and how can you benefit from it? So let's start with what is 0 to 1. So the concept was popularized by Peter Thiel in his book, but it existed a lot more, but he's the one who got it famous. And it doesn't have to be always a technical project. It can be you building a community from scratch, or like you building your career from scratch, like as a beginner. So any of these things can be considered as a 0 to 1 effort. And it's all about driving innovation and having some competitive edge over what exists already, and also learning as you do it. So how do you identify 0 to 1 opportunities? So when it comes to innovating something, you always have to spot it at some point. So what are some of the things that you could do, or like how do people stumble upon these opportunities? So the first thing is spotting gaps and needs. So always look for what are the pain points. What does customer actually want, or like what is something that has been bothering you about something, and trying to solve those actually gets you to that 0 to 1 moment, or figuring out something that is like actually valuable, or like something new, something that is not existing at the moment. And that's what actually you have to look deeper into to build your unique value proposition. How do you make your product or feature unique from what is existing? So you build it around the user pain points, identifying what wasn't existing before, what are you bringing in. And then the other method is, or the other area is finding the area of stagnation. So what is something that has been existing for a long time, but it has been monotonously growing, or like something didn't change for a while? So that's also an area of change that you could work upon. For example, if you take Airbnb, hotel industry has been there for a while, and everybody has been using it for a while. But Airbnb redefined it. So they brought up a newer face to it and also marketed it in an entirely different way. The other one is actually reframing an existing problem. So this might be already existing. You might have been already using it, but you could reframe it in a different way. An example is Uber. Taxi industry was always there, but Uber defined it into gave a different aspect of it, or a different look and feel to it. So those are some of the things you could identify some of the 0 to 1 efforts. Now let's talk about the phases of 0 to 1 project. And it's important to understand the phases so that you have a plan and a roadmap ahead of you, like that you could work on it. So the first one is ideation. So identifying the opportunity itself is part of it, figuring out like what you need to do, what is your unique value proposition, what is the, like who are your customers, or like who are you building it for, and why are you building it for? And you need to align your stakeholders at this point. You have to figure out like who are your supporters, like who is the team of believers that you're going to have along with you. And the next phase is planning and prototyping. So this is when you actually break down the bigger problems into smaller things, or like more actionable steps. Identify what you can do, set up milestones, what are the metrics that you want to measure. Like it has to be both quantitative and qualitative, so that you can measure what success looks like. So you get a product out in the market, like you can't just keep going without knowing what it is about, or like who is using it. So you will always need a plan on measuring all these things. And this is when you do all these things, and prototyping is a key part of it. So you have to test it out first to see like, okay, you have a great idea, but how do you build it? So start from scratch, build the minimum viable product out there so that like you can send it out for the users and testers to see how it works. And once you have the MVP, then comes the third phase, which is execution and scaling up. So at this point, agility is very crucial, and you have to keep your team motivated. You will encounter a lot of troubles, you will encounter a lot of failures and successes, of course. But at all these times, you have to make sure your team's morale is up, and they are working towards the end goal. So getting feedbacks from customers or internal users, all these things are very crucial at this point, and you need to pivot when needed. So sometimes you might have developed something, it worked out well for a while, but things changed. Like you have to pivot at that point, figure out like what would solve this problem or stagnation, or figure out what you could do next to get it to the next phase of it. And that's an overview of the phases. Now, let's talk about a bit about leading the 0 to 1 projects. What are some of the key things that you need in order to lead a project or lead a 0 to 1 project? So it's not just applicable to 0 to 1 projects, it's applicable to everything, but very key in some of these things. First thing I always highlight is visionary leadership. So you need to know what you're doing. You need to have a plan for the future. So when things go wrong, this is when you actually show your leadership and say, hey, this went wrong, like we learned this, let's move on, let's take the next step. So anticipate what might be coming your way and try to address them in as detail as possible. Adaptability is the next one. So when it comes to 0 to 1 projects, you'll encounter challenges, you will have a lot of success and a lot of failures from which you have to learn. So when you encounter something that is not working, analyze what you have learned so far, what was good in it, what are the learnings from it, and adapt accordingly. So if you need to pivot, if you need to ditch the entire thing and redo a piece of it, go for it. So you need to be able to have that resilience to figure out like what was wrong and how you could address it. Adding bandages on something like can't solve it only to an extent, so you'll have to be agile and adaptable for that. And communication. Clear communication is an essential skill at any point of life these days. Be very transparent to the stakeholders, keep them posted about like what are the updates, what is done so far, what was the impact of it, and what is your future plan for it. So making these known to everyone keeps up the energy, and also you'll have that circle of people who believes in you, your vision, and the product or the feature. And data-driven decision making. That's the next point and a key point. So whenever you start something, you might not have something, but as you grow, as you build newer things or add more and more details and detailing to it, you start getting the data. So that's when you have to take a look at it, take a deeper look at it, figure out what needs to be done based on it. And this is a key thing when you are agile and pivoting. So when you decide to go a different way, you must make use of these data and come out with a plan based on what you're seeing, what is the trend, and how could you make sure that the next step that you're going to take is something that is going to actually work or like at least change the direction. So those are some of the things that that comes up always. Other than that, some of the things are like risk tolerance, strategic thinking, team building. All these things are always key when it comes to this leadership of 0 to 1 products. So next, let's talk a bit about some of the practical steps. So when it comes to a 0 to 1 development or product development or whatever you do, the first thing is identifying the real problem and reframing it. That is a part of the phase 1 that we discussed a bit before. So you look at the pain points. You could lurk in forums about like what are the problems, or like figure out, talk to people, talk to users of existing products in similar aspect, and see what their pain points are, and reframe it in a different way so that you know this one, when done in a different way, could solve such and such problem. So one of the example is earlier people used to own CDs, and that was redefined to Spotify, iTunes, a lot of different things. And second one is start small but think big. It might be a very small idea that can start into a bigger product or anything. Facebook started as just for the Howard University, not for the whole world. So you test it in a smaller aspect or smaller subset, and then build it out. So it always works out because you know you have something, some learnings from where you started, and it keeps you going beyond what it was at the beginning. And assembling a team of believers, the people around you, your stakeholders, if it's a product or tech product, like the developers, testers, product managers, anybody around you, you need to have a team who believes in all these things so that they also have a shared goal of getting to the end product or getting into the next level. Sketching a wild but simple solutions. Some of the things might not be a big deal to work out. So just something that just came to my mind was I was interviewing for a role, and the question was it was a difficult question. There was one last bit I had to figure out. I just had to do a +1 to it, but I made it overcomplicated by adding like inner loops and multiple loops. So you don't always have to go to that complex solution. Sometimes the solution might be very simple, and always keep that in mind. And test fast and learn faster. Again, goes back to the point of pivoting, learning from data. Ask, did it actually solve the problem, or did it actually make it worse? So learn from every single step and iterate faster. Again, brings to the next point of iterate relentlessly. So make sure that you get feedback from users and also your team of believers, which we mentioned. Double down on things that actually worked and kill what didn't work. So some of the tools that we've used in the past, like when I was working on 0 to 1 efforts, was FullStory was a very played a key role in some of the things. We used FullStory to identify how user interacts with the product. Whereas where do you see a lot of aggression? Like, is there any place where people are actually getting stuck? Because as a developer, I might feel, okay, this particular button being here, like it works. But as a common person who is using it, it might not be that way. So make use of those tools to identify what are the pain points, or like what are the things that didn't actually work or causing some disruption to the user. And think of sustainable growth strategies. Your goal is always for long-term vision, and also you always have difficulties in like resources or time. There will be a lot of crunches around you. At all these times, you have to have a sustainable growth strategy. Like, what next? How do you plan the next steps? All these things have to be kept in mind when any decision is being made. So let's talk a bit about the impact. Measuring impact over profit. So when it comes to product, and it's very early stage, profit might not be an option at very early stages sometimes. So one thing that you can always measure at that point is what is the impact that it has created. Even when startups go for the funding, like they keep projecting the impact that they've made over the past few years or months, so that they can highlight this is what they were and this is the impact that they created. So always have that mindset of measuring the impact. And it's also leaving a legacy behind. Anything that you work or develop, that's actually a legacy that you're leaving behind. Your learnings, your mistakes, your successes, everything is something that you're leaving for the next generation or the future people who come to the future teammates to learn from as a legacy that you left behind. So Steve Jobs' vision for Apple was not just to develop products. Like, he entirely changed the vision of how telecommunication and entertainment, a lot of things worked. So when you think from that aspect, like it's not just about building things, and it's also about leaving legacy. And also creating opportunities for leadership and growth. So when you lead all these projects, like, you are not just creating opportunities for yourself, it's also for every single person of your team. So one of the 0 to 1 projects that I worked on, like, we just started as 2 engineers, and along the process, we both learned a lot. There was a 3rd engineer who joined. I was mentoring him. So it was giving me an opportunity to build my mentorship skills and also my leadership skills. So the other person in my team, like, she is a manager right now. She started with that project. So she also learned a lot of things along the way. So that's how, like, newer opportunities are being created, and you focus on the growth aspect of it. And you are being part of shaping the future of your organization and your team. A well-successful product which changed the history of the entire company is actually, like, when you work on something like that, it's actually, you are being part of that vision, and you are actually helping the organization itself to shape its future, what it looks like in the future, what is success defined for them. So when all these things happen, everything doesn't go always well. Like, there are challenges that are coming with it. So one of the things that always comes is ambiguity. So when you start something new, you don't know like what is to be done and what needs to be done. So there's always ambiguity. So you rely on like what do you know, what needs to be done. Breaking down to smaller tasks always helps in solving these ambiguity. And the next one is resistance to change. So not a lot of people are happy with newer things, so they like things as is. So you have a huge task of convincing people, okay, doing this change is going to support you or like the whole team itself, or it's going to solve such and such problem in a much elegant way. So having that knowledge about like how deep knowledge that you have about the product or the vision itself will help you navigate through all these things. And limited resources is something that always comes. You might not have enough people to work on, enough money to work on. Managing everything with the existing budget is also very crucial. You'll have to double down on things that like, this is when prioritization comes into a lot of place. So you might have an 8,000 number of features that you have in mind, but you'll have to prioritize with the limited resource that you have, like what would be a good one to start with. And failures and team morale, that is that's another key piece. When you have a failure, learn from it, and also when it is a success, keep celebrating it. Keeping the team morale up is very essential so that like you can end up with a successful product or feature, and maintaining the team morale is very essential for all these things. So one of the things that we always used to do is whenever we reach a milestone, or like, okay, we onboarded a new customer, we celebrate that milestone. It might be a simple coffee that we all go and have together as a team, but it's still a celebration. So make sure that you celebrate all these wins. And now what's in it for you? So there's a lot of things that I learned along the way. So one of the things is how do I manage all these like high pressure work at any point. Developing my leadership skills, driving innovation, how do I prioritize? All these things have been very much useful for me in learning new things and also building my career along the way. So some of the projects, like it got me promoted much faster than the existing tenure or like the existing path they had. So you learn how you could develop your skills, and also like personally how you could grow. So one of the things that actually helped me was prioritization of a lot of things. So when I started a leadership program, I knew like what are the things that I should prioritize first. When you start something by yourself, like there's a lot of things in your hand. Like you might have to do this, you have to start setting up the cohort, like you'll have to find the venue. But what comes first? So all these things I learned along the way when I was working on these projects, which didn't exist and had to be built from scratch. And of course, learning from the mistakes was always key. Growth and learning helped me a lot. So with that, I'd like to come to a closure to the session, and I want to emphasize on some of the key concepts. Having a clear vision is a resiliency to face uncertainties, and being adaptable when you have to pivot and need it. So it's actually fostering a new culture within the team yourself, and having an opportunity to head that is always a great opportunity to learn and grow. And with that, I'd like to conclude. I hope you had something to take home with you. Thank you. Maybe I have a few more minutes. In case anybody have any questions, I'll be around.
Slides are really good, and I got a lot from that, but I wanted to understand, like, if I wanted to pick up new people, if there was, like, a best way to do that, because right now, like, it's really easy to keep up, like, the team morale and do things like that, because there's 3 of us. So,
Okay.
like, I just text them, and I'm like, yeah, we're doing great, we made this progress, but if I wanted to pick up, like, 4 more people or another team for something specific, how would I maintain that while, like, growing as a startup?
So a lot of the companies now focus a lot on the cultural interviews, and that is to know how well you would gel with the team. So have the new members like talk to the team, like see how they work out the balance between each other. And of course, technical knowledge is key to it. But how I see is like if they have enough drive and if they have the knowledge, basic knowledge that they need, they'll be able to like cope up with it. There will be a ramp-up period for sure, but they'll be able to get it. So focus on the technical skills and also the soft skills, like how do they gel with the people, or a lot of the questions on like how conflict resolution is done is all helpful to know all these things. You know a person like when you talk to them for like, that's why all these interviews are like 45 minutes to 1 hour. Like you'll be able to figure out if there is a wrong signal that is to be found out, like you will be able to find it in that things. Mm-hmm.
So if I just wanted to be the only person in the business and I wanted to start it, and it should be a tech business, so what would be the best way to go around with it? And would you like learn the skills first and then maybe update the prototype, or would you just start with ChatGPT and keep building on the way while learning simultaneously? Because that's difficult too.
Yeah. If I were you, I would start building and learn along the way. So when you plan to, okay, you could spend a day or two, like, but time box it. So if you keep learning, if you have a thought of, okay, let me learn first and build it, 90% of the time you keep learning, but you never get to that point where you are starting to build. But once you start building, the learning is much faster. So I remember my first 0 to 1 product, it was at Microsoft, and I had to learn front-end development. I hated front-end development at that point, but I was like, okay, it's a new opportunity, let me give it a try. So the first week I spent some time learning new skills, React and TypeScript and everything, and then I felt, okay, I've been learning a lot of things, but I don't know how to use it. So I told my manager, okay, let me start building things so that I know how to use these things that I learned and I learned along the way.
Our last question. Can you talk a little more on, you're a Slack engineer, so like maybe like a day in the life or something like that, but I know that's not specifically tailored to
Yeah, sure. Yeah, so I am a senior engineer there. So we are a small team of backend engineers of 4. So each person owns a different feature. So most of the time, how the time is being spent is like whenever there's a feature, the first few days is focused on all the technical analysis and Spike and all these things, and then there's more focus on the implementation side of it. So I'd say like after the first few days of feature development, like there's a more time spent on the implementation side of it. We try to keep number of meetings less. A lot of the conversations are async. Even in Spike reviews, like we try to keep it async so that you don't have to be in a room like where you have no idea if you're interested in it or not. Once you post it, like every single person in the team has this urge to go take a look at it and see what it is so that they know what the other person is working on. I think we are almost at time. Thank you.
foremost, I've done this talk before, and so review of this talk. Someone told me, I remember your talk at Denver Dev Day. It taught me to appreciate my wife a lot more. So this talk might help you, or it might hurt your relationship, who knows. And so for those of you who are not familiar with dating apps or just haven't really seen the common tropes, I can go through them for you. There are a lot of really weird people there, hence this review. So first and foremost, you might have this person who is in a group photo or with their friend and you don't know which one they are. Or worse, they post a photo and you can't even see their face. Or worse, they're heavily filtered and you can't tell it's them. Or my absolute favorite is when they have a photo with a fish. So, all right, so this story starts in the 1700s with all this online dating stuff. So not in the 1700s, during that time it was not online dating, but in the 1700s, in case you're not familiar with US history, this was around the same time as Hamilton, pretty much. But this was during British rule, so colonialism was a thing. There were a lot of immigrants, so people from all over the world coming over here. The Great Awakening, so a lot of religious stuff, and the Declaration of Independence being signed where we are breaking up with the UK. So while all of this is happening, we had an event in 1727. I'm going to call it the Helen Morrison's ad. That is the event we're talking about here. And what she did was she became the very first person to post an ad in the newspaper seeking a husband, which is really funny because for about 30 years since then, men have already been doing that. And so when she did this, people were like, oh my gosh, this girl is delusional. And I was like, let me tell you a thing or two about being delusional, okay? So what happens? She gets sent to jail for a month. Yeah, so that didn't really work out, but a couple of centuries later, we had something called the St. James Computer Dating Service. So in 1964, this was the actual very first computer dating service, and the reason why I underline the word actual is because if you were to look up the first computer dating service or dating services in general, you'll probably or very highly likely get the results of these two guys taking credit for something that they didn't do. What's new? Well, actually, no, I don't know if they were actually taking credit. I love this. Y'all are traumatized, I can see this. But anyhow, this woman named Joanne Ball, she was a natural matchmaker for her friends, which means she had a lot of friends, she knew who would pair up with who, and sadly, she actually died single. But at the time, once again, in 1964, marriage was a necessity for women because of the wage gap. Actually, they didn't even have the permission to have their own bank accounts at this time, just to give you some perspective. And so what she did, sadly, I don't know exactly how her app or service worked because I only got so much information from the interweb, but it focused on qualities that you disliked and won't tolerate in a partner. So I'm just imagining two people matching up and he's like, here are my deal breakers, let me know your red flags and let me decide if I can deal with them. So this was the very first one. Now next, Operation Match. This was in 1965 and these are the two guys who made the very first computer-based matchmaking service in the US. So there were these two guys in college who were struggling to meet girls. Yeah, and then they decided to start this service where you fill out a pamphlet about yourself and your dating habits, and here's the process. So you fill out this questionnaire pamphlet, and then you mail the pamphlet with $3 in cash, and then the answers are then transferred into punch cards. They are manually transferring these things into punch cards, and then they run it through this computer at 2 to 4 a.m. And if you're wondering why it's 2 to 4 a.m., once again, they're students, so they go to school in the daytime, and they want to use this computer, and it's cheapest during those times. So after that, 2 weeks later, they get a list of people and their phone numbers of their top matches. And so some examples of the questions that were asked, so basic information, their name, their age, attitudes. So question, do you think romantic love is necessary for a successful marriage? Situations, this is actually straight from the pamphlet I read. So in a snack bar, you overhear a college girl saying how her roommate, these are oddly specific situations, but that is what it was. And then finally, physical appearance. And if You want to scan the QR code. I'll actually link it at a later QR code, so don't worry about it. But that is the actual pamphlet if you're interested. So how did it work? I don't know. Exactly. But here's what we do know. So most of the questions required you to rate or answer from a 1 to 5 scale. Also, the closer the answer, the higher the compatibility score, which I'm pretty sure you all could have guessed by now. And so here's how it maybe would have worked. And I definitely just kind of like oversimplified it for the sake of me not trying to build an app myself. So data encoding, weight attribution, similarity scoring, pair matching, and output generation. So first and foremost, data encoding. So for example, you have to give their answers numerical values. So for something like yes or no, it might be yes, okay. So giving yes or no binary values. So for example, are you willing to date people from outside your own area? So if you say yes, it might be a 1, and no is 0. Now, why have I not been standing up back here? Secondly, give ranking answers ordinal values on a scale. So for example, how important things are. So indicate your interest in German language customs. That was actually one of the questions. Like, tell me, how interested are you really about German language and custom? Very interested, not interested, and yeah, so those are pretty much the rankings that you could use. And this is a JavaScript talk, and so I did a couple code blocks for you, but also I'm not going to do dirty because it is also the very last talk of the day, so you're not going to watch me up here in code. So secondly, weight attribution. So giving each question a different weight to show the importance, because I'm pretty sure do you want children and do you like plants are going to be very differently weighted questions. So do you like dogs? Let's say this person has a weight of 3. It's pretty important. Once again, do you want kids? Do you like hiking? Once again, do you like hiking versus do you want kids? Very different weights or values, at least for me. And once again, the German language, we're really caught up on this in case you couldn't tell. So, whoop, quick little code snippet there. Now, we're going to use our favorite people, Alice and Bob. So let's assume that these are their answers. So after that, you have this, what happened? Where did my, you can imagine there, oh my gosh, Okay, cool. So let's say those are their answers, and there are supposed to be some numbers there, and clearly there are not, so, Once again, a little code snippet. Now, similarity scoring. So with that, the information that you had in the last slide, you're going to calculate the differences in their answers. And so, for example, here, do you like dogs? Do you want kids? Do you like hiking? Whether it's a yes or no, that is what goes in the parentheses, and you're going to square that. And after that, you're going to add up the sums, and then based on the sum is how you find the Euclidean distance. And for those of you who are not familiar with the Euclidean distance, fret not, because I will tell you what it is in like 30 seconds. So, yeah, so it's pretty much the distance between how close you are to other people. So Alice is right here, and for example, there's this, what is there? All right, so on the y-axis, you have members of the opposite sex consider me A, and then they fill out whatever it is. And then below that, so how important is physical appearance to you? So over here, you have Henry, who thinks he is like hot stuff and was like, yep, I'm a 4. And then how important is it that the other person is attractive? He said not really. So clearly, he just wants to be the hot one in the relationship. Next, okay. So Alice there, as you can see, David, Charlie, and Bob are the people who are closest to her. So they are the K nearest neighbor. And based on the Euclidean distance, that is how you calculated that. Now next is pair matching. So let's use some sample data. So consider this a dictionary that the Euclidean distances are between, you know, Alice and then all her other bachelors over there. And so the smaller the distance obviously means that you are the closest to them. And so based on that is how similar you are to that other person, which is pretty self-explanatory. And then step 5 is output generation. So here you're going to be sorted, we're going to sort the users by how similar their scores are in ascending order. So in this case, you get the top 6 users, and that is what is being mailed to you, at least in that one story, or like dating app story with the two college guys. So yeah, so those are the names and phone numbers that Alice is going to get. So modern dating apps, real quick show of hands. I'm not going to ask who's on them right now, but how many of you have at least heard of these dating apps? Okay, awesome, awesome. I can actually like tell who's kind of traumatized just by like looking at your faces right now. So I'm going to go over each one and what I just kind of like grasp from them. So how do people get matched? Well, I kind of know this one. And why I know is because for all these three sources, there's some sort of exposure of how they did things. And of course, they're only going to tell me as much as they want me to know. So OkCupid is probably the most elaborate one. This one was there's actually a book on it called Dataclysm, where the owner or CEO or former owner of OkCupid actually goes over how he did the matching. And once again, it's probably very limited to what he wants me to know. So OkCupid's 4 factors: match percentage, number of unread messages, a random number, and then attractiveness distance. So here's what we do know. So first, they're going to be given a question, and the user is going to have to answer what they want. They're also going to tell us what they want from another person, and finally, they get to put the value on how important it is that that question is to them. So once you add all that together, they take your data, they take the other person's data, and from there, you get the match, or the non-match. So match percentage, once again, Alice and Bob. And there's going to be an equation after, but just so that you know, common questions is going to be S, and for brevity, we're only going to go through 2. So the question is, how frequently do you bathe or shower? And and the options here are at least once a day, a couple times a week, or once a week or less. So I know. So she said once a day, or at least once a day. So that's how much she showers. She also wants someone with good hygiene, so she also wants them to shower at least once a day, and it's very important to her. Meanwhile, Bob asked the same question: how frequently do you bathe or shower? He also bathes at least once a day, but he's very forgiving, and he was just like, you know what, if my woman is just kind of busy, then a couple times a week is fine. And it's also not that important to him. So given this information here, another question. So are you a better conversationalist or listener? And Alice here is a listener. Oh, yeah, conversationalist or listener. And she is a listener. And she also wants a listener so they can just like sit in silence. which, you know, I kind of empathize. I didn't really think about this when I made the slide, and I was like, oh, that's what it means. And it's kind of important to her. Meanwhile, Bob here, he's a conversationalist, and he wants a listener so that he can just yap. And it's somewhat important to him. So earlier I mentioned that we have to assign weights to all of these questions, and so from irrelevant is going to be 0, and mandatory is going to be quite high. So how much did Bob's answer satisfy Alice? So here we start at 0, and then that 50 there is because it's very important to her. And he also said that he showers at least once a day, and so he fulfills that by 50%. Now, next, it's a little important. What was it? Conversationalist. And he did not fulfill that, so a 50 over 51, still pretty good. So it's a 98% satisfaction score. Now, how about the other way around? He finds showering a little bit important, and she at least, oh, did I mess up? I messed up. It's okay, y'all can imagine. But he finds it somewhat important to find someone who listens, and so she did fulfill that, and so here we are at 91%. Now, we calculate the final match percentage by doing this fun equation. So here with Alice's 91, we multiply it by the satisfaction score of Bob, and that's 98%. And then we take the square root, and once again, I mentioned that we're doing 2 questions, and so that's going to be S, and we are going to take the, yes, so there we go, number of questions, and therefore we're going to take the square root. And so we get a 94% match, which is pretty good, I would say. And some of you might be wondering, why didn't we just take a normal, regular average? And the reason for that is because the geometric mean, I'm sorry, I should have mentioned that it's called the geometric mean, but the geometric mean is just a better way to combine these values when you, again, you have different weights to the numbers that you are calculating. Now, unread messages. Unread messages translates to inactivity. So the algorithm is not working in your favor if you're choosing not to use the app, and so why would the app present more people to you, right? So that's the unread message factor to this algorithm. And the just-in-case number. So you can put your own preferences, you can tell people like exactly what you're looking for in a person, but the app is gonna be like, but what if you just happen to wanna give this other person a chance? And so that's the just-in-case number here. Now, as I was reading this book, this is actually a really sad graph, but the pink over there is how men rate women in terms of attraction. And so they think that there are a lot of very attractive people, while women rate men, or sorry, the opposite. I can't today, I'm sorry, y'all. But as you can see, the numbers are very different, and so what do we conclude by OkCupid? So by looking at this, you can tell that there are a lot of ugly men on OkCupid. And it's actually worse because the number starts at 1. So they're actually like half, like really ugly then. I'm joking, no. So what they actually did, oh yeah. So actually no, that's not true. They also conducted an experiment where they asked, you know, both sides without dealing with all this algorithm stuff, and you know, there are really good-looking people, both in the men and women categories. Now next, there was a behavioral scientist who did this hot guy versus hot girl experiment where they had two very attractive people walk around a college campus. And they would come up to random people and ask them questions in 3 phases. So during the first phase, they asked random people, do you want to go out? Do you want to go on a date with me? And both of them got relatively similar answers or percentage of getting yeses or nos. And second was, do you want to go home with me? And I'm sure you can imagine the girl got a few more yeses than the guy. He got about 5%. And then finally, because for HR reasons, I don't know if I'm allowed to word things that they are, but I'm going to let you all use your imagination. They asked, do you want to partake in an intimate activity with me? And the results here were that the woman got about 70% yeses, while the man, on the other hand, did not, they were not wanting to partake in such activity. And so, just to wrap that up, or at least for the OkCupid algorithm, you have your match percentage, the number of unread message, which again translates to activity, attractiveness distance, and the random number, the just-in-case number, right? And then, why am I going so fast? That's a timer. Oh, I got time. I need to slow down, y'all. So, next is Tinder. Real quick, how many of you play League of Legends? All right, everyone take a look around the room and identify the toxic people here. Well, that's why it's called a vibe check over there. But League of Legends, they use something called an ELO score, and an ELO score is the method for calculating the skill levels and rankings of users, which requires other people to be compared to each other, right? So back then, Tinder actually released this long message, and the TLDR of this very fat message is they used to use ELO scores to rank people, and now they don't. And I call BS on that. Now, so in this case, this is so sad. So this is why the man took his wife out to dinner after. So you have 3, quote, like levels of people. So you have the standard person, we're gonna call it player because it's pretty much a game, y'all, it's gamification. So player 1 has a ELO score of 100, player 2 has 200. And in this case, they identify people as a high quality, so the 200 is gonna be a high quality user. While player 3 and 4, they have scores of 60 and 50, and the algorithm is like, you are a low quality player. Grim, but true. Or not true, but like true in algorithm aspects. So I'm gonna assign these characters. So Alice over here, she's at 100, so she is a standard user, just started on the app. Bob up there, he's been here for a minute. He's pretty hot. Everyone wants to date him, and so he's at 200. Captain Hook and Ursula, not so hot. So, sorry. So, here is pretty much how we calculate it. Once again, we want to compare the level differences to one another. And what this is all pretty much translating to is that if you are a high-quality person and you match with a low-quality person, like you agree that you want to go on a date with them, your score just tanks. And theirs actually gets really, really high. However, if you are a low-quality person and you also match with, or if you are a high-quality person and you don't want to go on a date with this low-quality person, your score goes up a little more while theirs goes up or down a little more. And the reason for this is because the app is like, well, obviously, why would you want to go on a date with this person? Or at least for the low-quality person, they're like, you're out of, or like they're out of your league. So that's how that works here. And there is a decay factor. So this 0.4, can I count? Oh my gosh. Can I point? Yes. Oh, I can't point. It's okay. That 0.4 there is a value called the decay factor. So it's the multiplier that reduces the impact of the level difference on the score adjustments. And so it's not like just because one low-quality person matched with a high-quality person that like their scores just like diminish, or the low-quality person's score gets like super, super high. And so there's like some level of just moderating that, right? So here we're looking at Alice and Bob once again. She just started, Bob's been around for a minute, and they match. So as you can see, Alice's score goes up a bit, and then his goes down a bit. Now, if she was to not want to date Captain Hook over here, actually let me go back. So she's at 118, while Captain Hook here is at 60. If she decides that she doesn't want to go on a date with him, it's not that significant in terms of the changes of their scores. She's still going to be in that, quote, like standard area, and he's still going to be unwanted. And then Ursula here, so if she chooses that she wants to go on a date with her, so we're at 131 for Alice, Ursula's 50, and she chooses that she does, then Ursula's goes up pretty significantly, while Alice's goes down quite significantly, I would say. And so this is pretty much how it all works. And so the first round is when I was talking about Bob. After that, based on the score that you currently have, you continue to swipe and like not swipe on these people, and that's what adjusts your scores. And so at every step, the level that you're at is going to be updated. Now, so this is pretty much what we ended up with score-wise. All right. And then modern dating apps, once again, Hinge. Okay. So Hinge, how many of you have seen Love Island? I'm not super familiar with it, but I know a lot of friends who've told me about this, and I was very intrigued because it had to do with this Yale Shapley algorithm. And what this algorithm pretty much is it's saying that whoever you end up is the most optimal person based on your options. So here, so here we have Alice and Bob, you know, everyone in the picture at the moment. Now, Alice likes Bob, Ursula likes Captain Hook, Ariel also likes Captain Hook, but because Ursula and Captain Hook actually I'll tell you in a bit. But in this case, Captain Hook is liked by 2 people. And so he also chooses that he likes Ursula, and so they're the 2 that are going to be the most optimally matched. And basically what the Gay-Shapley algorithm is saying is that whoever's a leftover is just leftover, and that's like your option. So yeah, here Eric wants to be with Alice, and that doesn't work out because she wants to be with Bob. And so once again, Ariel and Eric, they are the leftovers. They are stuck with each other, no one else wants them, and that is exactly how my parents described their marriage. So let's just recap real quick. So we had Operation Match that took all of these factors, and that is how they matched people and sent their 6 names and phone numbers after you sent them $3. OkCupid, I'm so sorry, I'm going to go through these real quick. So OkCupid, I hope you remember what you learned. If not, then go back to the recording. Same for Tinder and Hinge. But ultimately, what did I learn? So computer dating services were created out of a gender equality. Once again, women didn't have the opportunity to make the money that they needed, and so marriage was a big deal to them. And this is how it pretty much started. And a lot of math is involved. So no matter the optimality, no matter how optimal you're trying to be, it's just objective. And so math is a great way to solve problems. However, dating apps are just ones and zeros, and so it really does not indicate or dictate what your value is, even though it's pretty grim that there's a high-quality person and a low-quality person on all of this. Yes, real quick. Okay, and then last but not least, Dwayne, he has a talk, or he's hosting a workshop. It's actually a brunch and learn, so if you want to come hang out with us on Saturday, that's a thing. And then last but not least, I'm so sorry this is not as fast as I wanted it to be. I'm Diana, here's my QR code. You can find the link to Dwayne's workshop on Saturday there. You can also find my contacts, but yeah, commit your code. You've been awesome, and thank you so much for coming to the very last talk.
Okay. Oh, yep. I'm too close to the speaker. All right, I'm coming this way. Yeah, this definitely feels like it's a little too... The heck? It didn't feel like it was that bad before.
Which one is the room one?
The room one is our main.
And what's this?
I have no idea.
So this is room?
That's room.
So it's all the way up.
Room is all the way up. We should probably turn that down and raise the other one. So I'm going to keep talking. I'm at -36 on the... All right, I'm at -36 on the mic pack. I'm so sorry. I'm just going to stand here because we're trying to get audio ready for tomorrow. So I'm going to talk like I'm talking to the room. I'm where I would be approximately from that speaker. So as you raise the room volume, we'll be able to simulate. Great talk, by the way. It seems super fun. All right, I'm going to keep talking. Are you raising the room volume now? All right, and then what? See ya. What? You don't hear it at all? I feel like I hear it a little bit. I mean, am I? It's only a little. Just raise it a little bit more then. What? Okay, then lower it, raise the other one. Let's get the room volume right, and then if we know that that's going to be high, we can lower OBS. And then we'll adjust OBS off of that. So I think that might be a little loud, a little bit. And we're going down, that might be close. I think that probably carries to the back of the room. Does that carry to the back of the room all right? All right, cool. And we're not getting really any feedback, I don't think. And what is OBS looking like?
We're in the yellow a little, but not too bad.
Okay, so we can turn it down in OBS though. But as long as the room sounds good, then we know we have wiggle room in OBS. We're in the yellow a little bit. All right, let me see. All right, we're gonna take a look at that. Yeah, I think like there's a loudspeaker that'll probably come through a bit much. So it's microphone, and we'll probably go down to like 9, 7. Close, and then how are we doing? If I'm projecting, this seems like it'd be a pretty good range to be at. The room audio